Well, hello, good afternoon. It's 4 p.m. Eastern somewhere in New York. It's 3 here in Chicago. We're really excited to be a Friday. I was so looking forward to the weekend, Mac. It's like, what am I gonna do? I've got like the whole week, the weekend now, and I had such a hard week in the basement here. Just working my tail off today.
That's what
Uh,
the week is like now that we're not doing 2 shows a day, 5 days a week.
I know, it's like, what do you mean? This is crazy. I got Tuesdays and Thursdays to like do house. Now my family apparently wants me to like clean up after myself and other things like
Oh,
that,
gee.
which is, that seems really inconvenient. I kind of like I'm sorry, I'm just too busy today. I'll see you at 10 o'clock tonight after Pete lets me out of rehearsal. Ah, there we go. We got our picture up. So, like everything in life, we have technical challenges. Now we've had 50 episodes, right? 50 we've done now. And what more fitting of a topic than fiber, right? Man alive. That was like on webinar number 3. Everybody's like, we need to do fiber. We need to do fiber. And I remember the 3 of us talking and going, man, who do you know? Who do you think? And we're like, all right, well, we worked a few connections, and we are like, yeah, still not coming together. Then we did the A2 panel, and the phone starts blowing up, and they're like, Jesse Madison, you ever hear of the fiber guy? I'm like, well, with a name like the fiber guy, that seems like a real professional name for this topic. And so I got hooked up by Tony Johnson, who's going to be with us. You probably remember him from the Broadcast Sports A2. Um, he connected me and Jesse up and the rest of our team, and we're having a little challenge today. That's why Jesse's picture looks frozen, because it kind of is. We're having some challenges with our GoToWebinar platform, so Jesse's able to join us by voice. The good news is he's got slides, which are in your handouts. But before we get into that, I'm going to let Mac talk about today's Q&A. And I think we're going to end up with quite a bit of dialogue at the end here. So I will tell you right away, Mac, just let everybody know,
Be
slides
specific.
first, slides first, then be specific, right? Mac is king of the specific islands. So talk about that.
Must be a very difficult topic because it just doesn't happen. For the one or two of you who haven't heard this spiel 50 times, in your GoToWebinar control panel, there is a pull-down menu that says questions. And at the bottom of that, when you pull it down, there's a little box for you to type in your questions, and we will see your questions. The other attendees will not see your questions. Please, when you're asking a question, be specific about what you're asking about, because your question certainly will not be answered immediately. And if it gets answered 5 minutes later, if you're not clear about exactly what topic that question is about, we will have no idea what you're asking. Same thing with comments, if a comment like, we do that all the time, it's meaningless if you don't say what it is you do all the time, because when we respond, it's not going to be that time. So please be specific in your questions and your comments. We will try to get to every question. Very likely we won't. We often run out of time, like 48 out of 50 times. But we will try to get to every topic to make sure everyone gets the information that they need. And that's about it for questions.
Yeah. Now, one thing, for people that think that you're like, just shut up, we want to hear from Jesse. That's great. You can keep thinking that. The reality is all of our attendees are still joining. So that's why we want to allow as much time as possible for our attendees to get linked up, because, I don't know if you know this, but a lot of the bandwidth is getting used in the world these days. So that's why we're kind of vamping a little extra time. I will say, Pete and Mac, we're going to have to do things a little differently today because of the camera challenges. And this, Jesse, feel free to let us know as you want to talk about like specific test gear that may be not in your slides, or after you get done with that portion of the presentation. We'll look it up on the web. We'll throw it up on the screen. If you find it easier to just do it yourself on your screen, we'll help you out with all that. This is live webinaring, and this is really about the knowledge that you have to share. I so appreciate you coming and being a part of this, even with the technical challenges that we're having. You know, Pete, do you have anything to add? It looks like we've kind of leveled off with attendees loading in.
The only thing is on your GoToWebinar viewer screen up on top, there is a little button that says Zoom. So you can use that to zoom in on the screen that Jesse's going to be sharing with you, which I'm going to turn on right now, and see things closer up if you want to see detail. Also on a Mac, you can just use 2 fingers to spread it out and zoom in a little bit there. So I am going to go and let Jesse
And
start.
I'm going to go.
And I am going to. I'll leave my mic on. And Jesse, if you want to go ahead and do your screen share.
Good to see it now.
There we go. We got your screen.
Got it.
Excellent.
Go for it.
Right. Well, hey, I just want to say thank you guys for getting in touch with me, and thank you to Tony Johnson. He's the one. He's kind of my right-hand guy whenever I do all things fiber. Most of you guys know him as an audio guy, but lo and behold, he's a man of many trades and many skills. And as for the camera thing, you know what? I've always been told I got a face for radio anyway, so this is probably for the best. What's really important is what's in the slides. My role in this setting and a very important aspect of my company is training. It's something I deeply enjoy doing. I've done quite a few classes, dozens of them all over the country for both private companies like Yamaha and Prism View, as well as a ton of broadcast and stagehand locals all over the United States. What we find is that it doesn't matter what level you are when it comes to fiber optics. If we do our job right, you walk away with some really good usable skills, day-to-day kind of skills you probably didn't have before. So the way we start the class is we just say, hey, you know, we're here to teach basics. How many times have you been on a show where people are actually chopping ends off and putting on new ends? If you work for the Golf Channel, maybe, but 90% of the stuff we do, that's not happening. What's more important is the day-to-day use of fiber, how to make it work upon setup. You know, let's get to lunch early. Let's not be scrambling around chasing our tails. Best practices, how to get the stuff done. So here for a little intro to myself, if you guys could go ahead and advance the slide. There it goes.
Yeah, so you should be able to in PowerPoint just pop that forward at some point here.
You would think that would be.
No, that's all good.
There it goes. Okay,
perfect.
So here I am. Here's my company. Got the website up there, got the email, and that'll all be there later. Got the phone number. A big thanks right now. I want to just give this shout out right away to IATSE. We all know who they are and what they do. They are huge training. The way we got this whole training thing started through Fiber Guy was with John Collini with IATSE. You guys know him as a former representative. He's a former V1 as well. I used to work on Skycam, and my V1 was John Collini. And when John became an IATSE representative, he got a hold of me right away, said, hey, let's do some fiber training. And it was right after I got my company started, and that's how it all got going. So IATSE has a lot to do with the way we launched this thing. Big mantra for me and my company in this training is tell me and I forget, teach me and I remember, involve me and I will learn. Today's restrictions means I can't put gear in your hands, so I'll do my best. But you know, we're all broadcast technicians and A2 stagehands. We learn by doing stuff. So if we ever are fortunate enough to run into each other in a class, I'll show up with cases full of gear and be throwing it at you as quick as you can get your hands on it. The agenda, and we kind of start out with an overview, how fiber optics work. We do have a video. We'll see how it plays with the camera challenges today. We didn't get a chance to test the video. If it doesn't, don't worry. We'll go through it. Big thing about fiber optics is it's replacing copper. Well, why is that? We'll go over it. Single mode versus multi-mode. Just like copper cables, there's different reasons for different cables. When it comes to copper, you're using different gauges and different connectors. Well, in fiber optics, when you're talking different gauge, really what you're referring to is single mode versus multi-mode. Types of cables and connectors, in other words, not only how to identify them, but how to choose the right one for the right application. Handling different types of fiber cables, just how to handle them. They're not copper, so we don't treat them like copper, but we also realize they're tougher than you think. Testing and cleaning tools. I'm sure a lot of you out there would like to hear from us as to, hey, what are your favorites? What do you use? We'll go through it. Fiber optic patch panels and bulkheads, different tools for different, when we're talking panels versus cables, we use different clickers, different things like that. And the biggest thing about this is just like everything we do, the devil is in the details. It's the little things repeated over and over again that's going to get you to an early lunch, as they say. I'm going to go ahead and give this video a try. Kelly, are you crossing your fingers?
I got it crossed, buddy.
Wait, let's see what happens. Dude. Okay. Enjoy this video for a few minutes, and after that, we'll go over it. Kelly, let me know if you hear it.
Oh, unfortunately, audio is not coming through. I saw you had a little mixer on your end. Do you have a way of coming out of the laptop headset into your little mixer? If not, we will share this with everybody later.
You know, another option, Kelly, would be to I sent you the YouTube link.
Yeah.
You would share it from YouTube to everybody. That would work.
Yeah. Why don't we keep stepping through, because that's basically the history of fiber, right? And kind of how we got to where we were. Corning and stuff like that. Yeah, let me work on that from my end, and let's kind of keep diving through with people, because you know they're obviously used to the fiber now. Let's take through the next step.
All right, so big thing, why is it replacing copper? The best analogy I can give you is it's like a goat path versus a superhighway. The amount of signals that you can get on copper versus fiber optic it's not even comparable. The biggest, probably the craziest test I've ever heard of, and this was done now a few years ago, back in 2014, some engineers in Japan wanted to test it and say, let's see if we can stress the bandwidth. Let's see if we can push the threshold of fiber optic, see just how much it'll take. So what they did was they went down and pushed. Everybody knows what gigabytes are. Not everybody knows what terabytes are. What they did was they pushed. I'm sorry, I should back up a little bit. We know what terabytes are. The next thing up is petabyte. Petabyte is the one I've had to find out. I had to Google that one a few years ago. They pushed 50 petabytes per second across 50 kilometers, and there was never even a glitch. If you're ever working on a show where someone even mentions the word petabyte, let me know and I'll show up. Just to be able to see that type of information traveling across any kind of show we're working on would be pretty incredible. The amount of information that's in there is it's inconceivable. You're never really going to be on a show where you do stress the bandwidth of fiber, and that's one of the biggest reasons it's replacing copper is you need less of it. Takes up less space. Density. You know, you take a rack that we're all used to walking into, whether you're in a theater or you're in a stadium, wherever you happen to be working, look at the panel that the truck plugs into, or look at the panels, the JBTs on the wall. Fiber optic connectors take up a lot less space, and you can get a lot more on them. Cost also, they last longer. The cable inside, believe it or not, once we get that Corning video up, you'll see they prove it. It lasts longer. It's a lot more durable than you think as well. When we get into some of the new stadiums, for instance, here in Minnesota, it was about 2016, US Bank Stadium was built. They had to decide, and I'll get you over to the next slide here. They had to decide what they were going to put in, you know, for copper versus fiber. If that stadium would have been built, say in the early 2000s, you would have seen a ton of triax. You'd have seen a ton of BNC. Well, in 2016, they kind of flipped the script, so to speak. What they did was they put in 55 strands of SMPTE and only 16 strands of triax. Though, for those of you that don't know, those are camera cables. Triax is as old as the hills. Triax has been around for decades and decades. Standard operating procedure going back 10 years ago, you put in a ton of triax and maybe a little bit of SMPTE. Well, that's been flipped around now. With SMPTE, you've got two strands going each way, and they basically take up a very similar size footprint on the panel, but you can handle 4K cameras, super slow-mo cameras. Triax definitely wasn't there in 2016, and it really isn't there now. There are things that SMPTE can do that Triax cannot. So it really is taking over. Then if you want to look at, just single strand fiber versus BNC, well, if you have 12 fiber inputs on a JVT panel versus 12 BNC inputs, well, those 12 BNC inputs can't even do a fraction of what the fiber lines can do. You can multiplex so many things down there, video or audio. So it really is. It's not a question of if or when anymore. It's here. And so teaching our people how to deal with it has become pretty important, and that's what we're hoping to do. You can see some of the bullet points up on the screen there. What I have up here is what I've witnessed, but it doesn't mean that's the threshold. You'll see on the third bullet point, up to 18 HD signals on one fiber strand. The fiber can do more than that. The fiber is just a glass tube. That's all it is, everybody. It's a tube of glass. It's a hollow tube of tiny little glass, and it's got light bouncing down it. It can handle as much light as you can throw in there. You just have to change the wavelength or frequency, if you will. So what slows it down are the boxes on either end of the fiber optics, okay? If you have 18 different signals, that means those 18 different signals are traveling on 18 different wavelengths, all right? Up to 64 channels of audio, you can do way more than that. That was just, when I put the slideshow together, that's as much as I had seen in person. That's one single strand. So envision a fiber optic cable. You're holding a TAC 12 or a TAC 4, a cable with 4 strands sticking out of there. You can times each one of those by 4. So if you could get 4 times 18, I'm going to go quick math here, 72. I get a bonus for that. And then 4 times 64, I'll let Tony come up with that one. I'll give you time, Tony. Pull off your shoes and socks and start counting. You do 4 times that. That can happen on one little tiny fiber optic cable. And it weighs a fraction of what a big heavy cable is. So think about shipping for one. You guys have all handled great big long 500-foot DT12s, things like that, audio snakes, video snakes. The amount of information those video and audio copper snakes are capable of don't even come close to a fraction of what a fiber optic cable is capable of. So shipping is another thing. It's so much lighter. As another big one people don't know about is it isn't affected by power or RF interference. We all know if you lay your video or fiber, or your video or audio cables, if they're copper, and you lay them in parallel, you lay them alongside of some feeder cables or some other power, you're going to get hum. You're going to get lines in your video. Fiber optic doesn't have that problem because the actual data and video are not being transmitted down copper. They're being transmitted down fiber optic light. So they don't have that problem. It's another very big advantage that it can offer. And more cost effective, as we kind of said. Let me check back in with you, Kelly. Did you have any luck clicking on that video I sent over to you?
Yeah, we found the Fiber 101, and Pete was just loading it up on his machine to
right, just break in when you're ready to send it.
We will, absolutely, and we'll just keep moving forward here. So unless Pete's ready.
Okay.
And judging by this,
he appears to be ready.
All right, and Pete, whenever you want to. Thanks for your patience, everybody. It's just a bandwidth day. And let's see if we can get the sound up to be heard. Pete, unfortunately, we are not hearing the sound again. And yeah, please.
I'm glad it's not just me. I feel a little.
No, you don't need to apologize. This is fiber.
I got it.
All right.
I'm just gonna put my mic up to the computer so you
There
can
you
hear.
go. There you go. We're old school. We're all good with this.
With nearly 2 billion kilometers deployed around the world, optical fiber is the backbone of today's most advanced telecommunications networks. Fiber is assembled into optical cables that link continents, cities, and neighborhoods around the world. This thin, flexible strand of ultra-pure glass is capable of carrying voice, data, and video information in the form of light signals at very high speeds. Let's take a closer look at this revolutionary transmission medium. Optical fiber is very thin. One strand is about the diameter of a human hair. It is comprised of two basic elements made of glass, the core and the cladding. The core, the center part of the fiber, is the area through which the light signals are transmitted. The cladding layer completely surrounds the core, keeping the light from escaping. There are two different types of fiber, single mode and multi-mode. Single mode fiber has a small core diameter designed to carry light in a single path over long distances. It has high information carrying capacity and low attenuation, and is the most widely deployed optical fiber in the world. Multi-mode fiber has a larger core, which allows light to travel down many paths simultaneously. Typically, multi-mode fiber is deployed in data centers, local area networks, and storage area networks, where it is more cost-effective than single-mode fiber. Corning invented the first low-loss fiber in 1970 and has continued to deliver significant performance improvements for the past 40 years through continuous innovation. Three key attributes that can limit the speed or information carrying capacity of the optical fiber are attenuation, dispersion, and bend-induced loss in the form of macrobending and microbending performance. Attenuation refers to signal loss along the length of the fiber. In this illustration, the light gets dimmer as it travels down the fiber. It can be caused by the quality of the glass itself or can be induced by bending. Dispersion is the distortion of a signal along the fiber length. This occurs because different spectral components of the optical signal in the optical fiber travel at different speeds. In this example, different wavelengths are represented by the red and yellow light. Macrobending and microbending are optical effects that occur when the fiber is bent from a straight axis. Microbending is an attenuation increase caused by high-frequency, small-radius bends along the length of the fiber. Macrobending is the attenuation associated with bending or wrapping the fiber. Both of these conditions can allow light to leak out of the fiber, meaning some of the original signal is lost. Using a bend-insensitive fiber like Corning ClearCurve single-mode or multi-mode fiber will greatly reduce the loss caused by macrobending. Optical fibers operate on the principle of total internal reflection, which keeps the light within the core and guides it down the length of the fiber. Refraction refers to the bending of light as it passes from one substance to another. The glass used in the fiber's core has a higher refractive index than the glass used in the cladding, so that the light can be trapped in the core by reflection at the cladding interface, as it propagates down the length of the fiber. Two additional characteristics of single-mode fiber that are important are cutoff wavelength and mode field diameter. Cutoff wavelength is the wavelength above which a fiber will support only a single mode. Wavelengths below the cutoff support two or more modes. The cutoff wavelength is determined by the fiber's refractive index profile, the length and bend of the fiber, as well as the cabling process and deployment conditions encountered during use. In a single-mode fiber, some of the optical power is actually guided outside the core. In fact, as much as 30% of the light propagates in the cladding layer of some fibers. The mode field diameter defines the size of the optical power distribution in the fiber. Multi-mode fiber has two important characteristics: numerical aperture and core size. Numerical aperture is the measure of the angular range of acceptance of light into a fiber. The angle over which a fiber accepts light depends on the refractive indices of the core and cladding glass. Core diameter is a fundamental design parameter of multi-mode optical fiber. The larger the core, the more modes of light can propagate through the fiber. Multi-mode fiber has a much larger core size than single-mode fiber. Optical fiber is strong, flexible, and reliable. Inch for inch, it's stronger than steel and more durable than copper. Fiber offers excellent signal performance over a wide range of environmental conditions. Since fiber carries light instead of electricity, it is unsusceptible to lightning strikes or electrical faults, and, unlike copper, it does not corrode or rust. As a result, fiber reduces maintenance costs and has a proven record of reliability in the field. In fact, it is common for customers to report to Corning that cables installed in the late 1970s or early 1980s are still in use today. Optical fiber is cost-effective, durable, and scalable, has low attenuation, and it features the superior transmission quality needed for high-speed transmission of voice, data, and video in today's leading applications. To learn more, visit our website or contact your Corning account representative.
All right.
All right, and we're gonna change presenter back to you. Thanks everybody for your patience with that. That was well worth the work, Jesse.
Yeah, so that video has been great. It really kind of dumbs it down for you, you know. Oh, this is light bouncing down a tube. That's what we're dealing with. And you start to understand some of the best practices and why we do them. And if you can see on the screen there, that's the tube of glass we're talking about. It's the same size as a human hair follicle. It never ceases to amaze me, not only to think about all the information that's traveling down that little hair-sized piece of glass, but that the middle of it is hollow. And if you ever want to really nerd out, go watch how they make it. It's so cool. They take, it starts with a great big open-ended cylinder of glass. They heat it up and stretch it out like Laffy Taffy. They stretch it out, and then it runs up this 100-foot cooling tower, dips into this chemical bath. It's cool for nerds like me to watch it. One of the most, we can get into this when we talk about anatomy of a cable, but I talked about the chemical bath. This glass works like a mirror. If you go into your bathroom at home, you got a mirror, and the back of the mirror is black. It's black because it needs to capture the light and bounce it back at you. Well, the chemical that covers the glass in fiber optic, it is incredibly proprietary and a deeply protected secret. Corning still has the best secret sauce known, just like the Big Mac. They got the best secret sauce going. They have found the chemical that contains light better than any other company, and that is a critical component to it. If you can't match up to what they're doing, then you're not going to be able to manufacture the stuff. All right, go back here. So let's talk more about single mode versus multi-mode. You guys saw it in the video. The multi-mode is a wider opening. Okay, single mode is a smaller opening. One of the analogies I like to use is everybody's a garden hose, right? On your
Jesse, one moment. Could you switch your PowerPoint to show mode instead of presenter mode?
Oh yeah, thank you. Sorry, I was just messing with that.
Yeah, there you go.
All right. So you can see multi-mode. It's a bigger, wider opening, and like your garden hose, you've got a setting on there that it'll go to the jet setting and it'll shoot the water in a tight stream all the way across into the neighbor's yard, right? That's single mode. Multi-mode is like the shower setting. There's a lot of water coming out, but it only goes about 10 feet, right? Well, that's multi-mode. That's exactly how the analogies work. Multi-mode is really used more for data centers. It's used a lot in audio. It can travel your signal a long ways, but not anywhere nearly as far as single mode can. Single mode is what they lay across oceans. There are fiber optic cables laid across the floor of oceans that encompass the whole entire planet, and it's all single mode. Multi-mode, you walk into an arena, a lot of the arenamation boards or the jumbotrons, they're feeding data to the scoreboard. But if it's video, it's typically traveling down single mode. Single mode just goes farther, faster. That's the difference. So you also look at the slide, you see single modes in yellow, multi-modes in orange. Multi-mode also shows up in aqua colored. Whenever you're dealing with patch cables, those colors are the first thing you should look for to know what you're dealing with. The big thing we want people to know about is, I'll say it now and I'll probably say it 100 more times over the course of the presentation. Read the side of the cable. On the side of the cables we're working with is all the information you want to know. And that goes for copper, that goes for fiber optic, anything you're dealing with. There's all kinds of information there. There's also distance markings every 2 feet on most cables. On fiber cables, what you're looking for is something like SM or MM, or it might give you a number. Okay, if you look at the diagram I have up, you'll see the numbers 125 and 625 next to multi-mode, 62.5. And then under there, you'll see 125 and 50. Then under there, you'll see 125 and 9. What that's telling you is the outer diameter of that piece of glass is 125 microns wide. The inner diameter, the opening for multi-mode, the orange type, is 62.5 microns. More recently, they switched to OS3 and OS4, which is the middle one. that opening's a little bit smaller. It's 50 microns. Then when you go down to single mode, it's way smaller. It's about 9 microns wide. Again, the smaller the opening, the faster it's going. That's why it's there. And a lot of times when you hear fiber techs talking about stripping fiber, getting down, they'll refer to the glass as the 9 micron. It's a term that's used a lot with people who are used to terminating. When they're talking about, they call it the 9 micron. Well, that's the glass they're talking about in single mode. So now you kind of know that single mode versus multi-mode. There's your dimensions, and again, you guys have this stuff, so you can kind of keep it for reference. They're very specific uses, very, very important reasons why you would use one versus the other. And then if you're someone who is in a position, maybe you work at a stadium or a theater or any concert venue, if you're going to order this stuff, then go back to this information. Know what you're ordering, know what you're asking for. We've been on a lot of shows where we pull into venues and the stuff you're getting from them, the connections you're plugging into the wall are wrong. And it's because, they didn't have this kind of information beforehand. So that's one reason we like to share this stuff. And I'm going to get into some other basics, color codes. And I always get to this point. I know I'm going too fast. If there's any questions, please don't be afraid to throw them at me. I know we're going fast. So I just want to make sure to give anybody opportunity to ask any questions on single mode versus multi-mode. Color code. A lot of us know and are used to the electrician's code, or if you want to call it the video code. This one's different. This one comes from the telecom. Telecom had their own code, and it got adapted by fiber optics. I love memorizing this thing because in a lot of stadiums, this stuff got put in a long time ago, and it's not numbered correctly, and it's not labeled correctly at all. Sometimes things will crisscross. Well, if I can look at the back of a panel, usually what's plugging into the back of the panel are colored breakouts. They're the little tiny fiber optic glass with coating around them that is colored. So if I can look at the back of a panel and say, hey, we're on blue, we're on orange, we're on green, well, I know what numbers they are. So it's just another really good basics kind of fiber 101 to know that code, know that number. We don't have any vulgar sayings made up for this one like they do for the electricians or the video code, but if somebody wants to come up with one, I'll gladly, we'll give away a prize. How about that? I do have a prize to give away. We'll give away a free little laser. Somebody can give me a clever saying using the code. I'm not going to put any rules. If you want to use vulgarity, I'm not going to stop you. We'll give away a laser, a free handheld laser for that one. All right, so moving on. Types of connectors. So this is one where a lot of you will recognize some of these, and some of these connectors you probably will not. Let's talk about the anatomy of a connector to begin with.
Jesse.
Everybody knows what a boot is. The boot is the backside of it. The black gives it the
Hey
strength.
Jesse, it's Tony.
Yeah.
I just got a question in here.
Yeah.
They're just wondering what is easy to work with and difficult to work with, meaning when comparing multi-mode and single mode fiber.
Well, you couldn't really say. I'll go ahead and say multi-mode is probably easier to work with, and it's kind of for a dumb reason, to be honest. The opening is bigger, so therefore a little tiny speck of dust is less likely to interrupt your signal. So in that matter, multi-mode might be easier to work with, but you got to keep it all clean. But multi-mode is definitely going to have a more of a tolerance for dirt and dust than single mode will. A 9 micron opening versus a 50 or 62.5 micron opening, you could say that multi-mode is more forgiving in that manner. The rest of it is all the same. There's really no other difference than the size of that opening as far as working on it hands-on. Good question. Thank you. Continuing with the anatomy of the connector, you got the boot on the back, and then the locking mechanism housing. We're all very familiar with that. What's different about fiber optic connectors are, number one, the keyway. You see the keyway there in the little orange arrow. The keyway's there to keep you from spinning these connectors on each other. When you plug one into another, you don't want them spinning back and forth because they'll scratch each other up. So the keyway's there to lock it into place. And then the ferrule, the white tip, that's probably one of the most commonly broken parts of this connector. It's made out of ceramic. So it's glass. It's tougher than you think, but you get it in there, you get it kinked sideways, you start forcing it like we're not supposed to, and that is one of the most common breaks we see is the ferrule. The ferrule is actually hollow too, and we'll see some of that later. But basically, when you terminate this stuff, you slide that little tiny piece of glass right through the end of the ferrule, and then you trim it off using a sapphire or ruby blade, and then you sand it down with this diamond grit sandpaper. That's how you terminate it. It's awful work. Don't ever try it. Just do fusion splicing. But yeah, the glass is literally it's sanded down flush with the end of that ferrule. So it's the end face of that thing that you really have to worry about keeping clean. Moving on to the next one, anatomy of a cable. Again, this is a lot like any other cable you're talking about, but what makes it different is the yellow, blue, and the core. Jacket, yeah, we all know what a jacket is. Different types of fiber optic cables have different types of jackets, okay? If you have a tactically rated fiber optic cable, that's some of the toughest stuff out there. Tactically rated means it can hold up to certain crush tolerances, bend tolerances, heat tolerances. It's rated tactical because the military are the ones who led the way on that. And then you have other types, we'll get into those later, but inside of that, you got the strength members. The reason that's yellow is because a tactical cable uses aramid yarn. It's literally a woven yarn that's inside there that it gives it all of its strength and gives it, pull strength, bend strength, crush strength. A lot of it comes from that yarn. When you peel away the yarn, you get down to the cladding. This is a term you could also call that the furcation tubing, which is probably more accurate. But just like if you're splicing building an XLR connector or a video connector, you peel away the layers, you see the last layer, it's usually a different color. Underneath of that cladding, you'll see the glass, but the glass still has another coating around it, and that's, if you remember me talking about the special sauce, that coating is when you see the core on there. You have to peel off the coating before you terminate it. So that coating is what keeps all the light inside. So now if you strip down a fiber optic cable, that's exactly what you'd be looking at right there. Again, the core is the glass. On top of the glass is the coating, the special sauce. And then you've got the furcation tubing or cladding, as it were, in this anatomy, and then the yarn, and then the jacket. So that's what it looks like when you take it apart. All right, now we'll get more specific about these connector types. On the left, you'll see anaerobic. The word anaerobic just means absence of air. Anaerobic is used in a lot of different industries. It's a tougher connector. It's a better, more robust connection. It's meant more for permanent type field cables. The one on the right is Unicam connector. Unicam is meant to be plugged in, say, in the back of a data rack and left there. It's really not meant to be taken off and put back on and taken off and put back on. It's kind of a plug it in and forget it sort of connector. It's also really quick to put on a Unicam versus an anaerobic. Anaerobic is a little more labor intensive. The next slide here. With the anaerobics, if you're not fusion splicing, which a lot of people are, anaerobics are cheap to buy, but a lot more labor to them. They're assembled on site. So when you're looking at just the connector, if you have a stripped down cable ready to go in a connector, you have to take a syringe and you inject an adhesive inside of the connector from the backside, fill it up, and then you slide the cable through. It's tedious work. I mean, it's kind of an art form in some ways. They're typically made of metal. They're more durable and common. I would say they're more common on your field cables for sure. More affordable, yeah, to buy, but not to put on. Requires hand polishing, my favorite part. Hand polishing. If you're really good at sheetrocking or auto body work, you may enjoy it. If you're not, you won't. Hand polishing is literally wax on, wax off. You're sending this thing putting the connector in a little puck and doing these figure eights on this diamond grit sandpaper. It's quite the process. Once you get good at it, it's not too bad. But yeah, people much prefer fusion splicing nowadays. Used in harsh environments, absolutely. You'll find these connectors in military, industrial, mining, TV broadcast. Who's more harsh on gear than us, TV broadcast technicians? Unicam connectors. These are pre-polished and pre-assembled, so no assembly on site really, Tony and I have put on, I don't know what, Tony, millions, trillions of these things. They go on pretty quick. When Tony and I set up doing these things, he'll prep the cables and I'll do the terminations, and we can knock them out in about 90 seconds per connector. And then, like I said, they're made to be put in the back of a rack and left there. There's no adhesives needed. They are, yeah, of course they're less durable. Most of them are made out of plastic. More money, yeah. Retail for one of those connectors is like $15, $17, give or take. They're expensive, but they save you a ton of time. They terminate quickly, like I said. Plastic, yep, used in permanent installs. We covered all that. All right, moving forward. And one thing I want to say before we leave this is, I'm sure there's some of you that you might run into some cables sometimes where you're on a job, they open the cable trunk, and there's a bunch of fiber cables, and every once in a while you might see an end like this. To be honest, to kind of, one of the things I like to do is kind of empower people to let whoever they're working with, your producers, your tech managers, let them know that you know about this stuff, okay? If you open up a trunk or a case of cable and you see a couple of these connectors on them, go to your tech manager, go to whoever's in charge and just say, hey, I have no problem running these cables, but I just want to let you know these are really likely to break and I don't want to be held responsible for it. These are not meant for the field. These are unicam connectors meant for permanent installs, not meant for field cables. And yeah, some people will take that better than others, but I could tell you if somebody came and said that to me, I would have a lot more respect for them because I know they're more educated than the average bear. So don't be afraid to call that stuff out when you see it. And we'll talk more about when certain types of cables you can identify later too. All right, types of connectors. This one's probably the most common, an ST connector. It's a lot like a BNC. Audio guys use a similar type of housing on some of your antennas I've seen. It goes on a lot like a BNC. One of the big things I want you guys to remember, if you're taking notes, write this down, 2.5 millimeter ferrule. Remember, the ferrule is the white tip that sticks out from the end made out of ceramic. The outer diameter of it is 2.5 millimeters. That's a very important number to remember. Reason is because when you're buying things like cleaning tools, inspection scopes, adapters, you need to know what you're buying and what you're looking for. 2.5 will come up in the model numbers of all of that gear I just mentioned. It'll come up in the questions you get asked by whoever's selling it to you. 2.5 millimeters is very important, and a lot of the connectors have that same diameter. So remember that. With an ST connector, you can get them in single mode or multi-mode. The inner opening has nothing to do with the outer diameter. So they'll come in either modes. Use an AV broadcast. They're used all over, to be honest, but that's where we see them, of course, more common. If you see them in plastic, try to avoid them. The plastic ST connectors are really bad for failing. They get cracked easy. And a big thing with these cables, and like any cables, reseat them. If there's a problem, start simple. Just reseat them, undo it, plug it back in. You never know, that might do it. So moving on to the next type of connector. Oh, hey, one other thing about the ST should tell you guys is when you're talking about them, I always say Sam Tom, or in this one, LC connector, Larry Charlie. I don't say ST or LC very often because they so often get confused with all the other connectors. They sound a lot alike. So just another best practice we usually do. So communicate a little better and you don't get the wrong stuff. LC connector stands for Lucent connector. These little devils, they break easy, but they're pretty handy because they're so small. You can get a ton of them in small places. You'll see them a lot on fiber converters, your Asha boxes, your Fidos, your telecast little converters. You see a lot of them on the rattlers. Rattlers are typically ST, but they're cheap, they're handy, but they break really easy. I'm not a huge fan. Here's the big thing about them, though, is they have a different size ferrule. You'll see there up at the top of the bullet points, 1.25 millimeter. That's another one you should write down. You're going to run into this a lot if you're going to interface with fiber. You want to have the right tool for the right job. So 1.25 millimeter, that's gonna be able to get on, whether it's a scope or a clicker, that's going to be able to get on an LC connector or an LC input. Use the AV process broadcast. It clicks into place. There's no spinning and locking like the ST. And yeah, the tabs are weak. I mean, they're like the old phone cables, right? They break easy. So if you see them around, I- here's one for you audio guys out there. Tony, you can speak to this. A lot of you guys are working with what I would call a booth box. Or if you're in AV, you might have a backstage box that has everything in it. If you see these connectors, a lot of times the way they get built is they're sticking out of the booth box. They protrude from what it is they're sticking into. Well, they get clunked all the time. So what I tell people is, if you see a little short LC connector that's a critical part of your broadcast, go get a spare on your next trip back to the snack bar. Go get a spare, bring it there, and stash it, because those things get broken. And what's Murphy's rule? Murphy's law. They always get broken at the worst time. Well, if you're the guy standing there with the spare and the fix, you're the hero. So just a good thing to keep around, especially for those little weaklings. I'm going pretty fast again, Tony. Any other questions? Anything to throw in from your side?
I was just going to mention there's quite a few questions in here. I just wanted you to get through your connectors and then we can.
Okay, I'll get through the connectors. We're not too far. Next one is SC. I call this one Sam Charlie. SC stands for square connector. These guys just slide and click into place, but they look a lot like the LC. They're oftentimes confused. They're fairly popular. A lot of times used in data centers as well. They too have a 2.5 millimeter ferrule. So I want to take this moment to mention another little trick, just like having a spare cable with you that you got from the truck because you saw an opportunity of failure, so you got a backup. When you are on a show, I'm sure a lot of you have been there where everybody's running around looking for the right fiber cable, the right adapter cable. Well, here's another trick you can use in some cases. If it's a connector that has a 2.5 millimeter ferrule, like our friend Mr. Sam Charlie and Sam Tom do, sometimes they'll fit into whatever box you're talking about. Not always, but there are times where they will. So think about it next time you're on a show. Hopefully that's soon, right? Take a look at some of the boxes you're using and just think to yourself, hey, is the sleeve open, the input sleeve? Could I get an SC connector on there, Sam Charlie, just like I could get an ST? Those are tricks that have definitely saved the day for me in multiple occasions because of the boxes. RF fiber boxes are often, they have exposed sleeves and inputs. So if it's a 2.5 millimeter ferrule, you might still be in business, even though you don't have the right cable. And there again, the guy that comes up with that fix, the guy or gal who comes up with that fix is going to be pretty popular. Like I said, data centers clicks into place. It's kind of a push-pull sort of connector. Used to be more expensive, less common. That is definitely not the case now. Tony can attest to this fact. We have a college hockey arena in Minneapolis called the Mariucci Arena. And no, Tony, I won't call it 3M Arena like it's been renamed. It's still Mariucci to me. They hired a fiber optic company to come in and put in a bunch of connectors and terminate them where the truck parks. Well, these guys had never done a broadcast in their life, and nobody thought to ask them, hey, you want to make sure to put in the same type of connectors that the TV trucks are used to using. That was a step that got skipped. Well, they put in these type of connectors. And the first time the truck showed up, I got a call because my shop is not that far from there. And they were saying, hey, do you have any adapters? Apparently, the fiber we have to use here now is all SC. So these things they'll show up in places you wouldn't expect them. The best advice I could give is have a couple. They're cheap. You can get them for 10, 12 bucks a piece. Have a couple of these different types of adapter cables with you. Keep them in your toolbox like you would anything else. They can really save the day if you're in the right place at the wrong time. Last bullet point there, available in duplex mode. Yeah, simplex or duplex is how they call, a double or a single. Same with LC. They often show up in duplex mode, and oftentimes they're cheaper to buy in duplex mode. So you can peel them apart by hand if you have to. Last one we'll talk about for now is Frank Charlie FC connector. I'm a big fan of this one. It is somewhat prevalent in RF fiber optic converters and transmitters. They have a thread-on locking mechanism, which is great for testing. A lot of it's very popular with the overseas stuff we buy. The testers, if you have a cable that will thread into place on your tester, it's not budging at all. And as you saw when I showed you that clip with the Sigma versus multi-mode, This laser beam is tiny. If it's single mode, 9 microns, that's a tiny, tiny little beam that when you make a connection, those two beams have to align with each other. If they are off by 1 micron, your signal is going to suffer. So this type of connector is actually pretty good to use when you're doing testing. You put it into your tester. The other end of it, if you have an assortment of adapter cables, can be Sam Charlie, Sam Tom. They make them for every single scenario. You can adapt anything into anything when it comes to fiber, much like copper. Again, we run into the same thing, 2.5 millimeter ferrule. So again, this FC guy could come in and save the day where everybody thinks you need a Sam Tom. You happen to have a Frank Charlie, and you come in and say, zoop, it fits. Boom, the signal goes through. So again, keep an assortment with you if you interface with fiber often. They are somewhat rarely seen, but becoming a little bit more prevalent from my experience. They don't, they're a little bit harder to find. So if you want to get some of them, let me know. I can definitely, we sell all this stuff too, guys. I don't like being a traveling sales guy, but we do sell all this stuff. And the best thing about buying through us is we're going to give you the best advice, not just the product we make the most markup off of. We go off of reputation. So you see stuff on here you want to buy, don't be afraid to let us know. Let's stop there. I won't go through SMPTE connectors yet, Tony. Why don't you throw a couple
Yeah, I was just gonna say a few questions in here now. Starting with this one is how do you identify a unicam on site? I think I'd reference the picture that you had.
Let's back up
on your slide.
If you look at, actually, I'll go back to the side by side here. If you see on the right the unicam, if the person asking, I would say if you're more of someone who runs into more of a video setting where you're dealing with tactical cables or just field cables, often the dead giveaway is, for one, they're plastic versus metal, and number two, that orange amber kind of housing you see on the top of the circle, those are another dead giveaway when you see that orange amber. And if they're on a cable, anytime you're dealing with a field fiber optic cable, especially what's a TAC4 or a fan out of 6 or 12, they should be metal. If someone's given you a cable to run any significant amount of different distance, it should be metal. If we're talking a little 4, 6, 10-foot patch cable, okay, fine, plastic, all right, whatever. I'd prefer metal, but plastic will do fine in a little patch cable scenario. But a field cable, when I say field cable, I mean 25, 50 plus feet, 100 feet, 500 feet. None of those connectors should have plastic on there. And like I said, you don't have to be a stinker about it and say, I'm not going to run it. Just say, hey, I know what this stuff is, and I don't want to be blamed if it's broken. But that's the dead giveaway for these Unicam ones. I hope that answers your question. What else you got there, Tone?
Another one is, does simplex imply single strand and duplex multi-strand?
Well, yeah, it's really used in patch cables. So this is a good example right here. When you're buying patch cables, and we actually have a slide that talks a lot about this, but yes, when you're buying a patch cable, you say, give me a duplex patch cable. That means you want a 2-strand like here. If it's a simplex, it's a single strand, just a 1-for-1 patch cable. But like I said, a lot of times they're actually cheaper to buy as duplex, and they break apart and peel apart where you can make 2 of them into 1 of them pretty quickly with your fingernails. So yes, to answer your question. What else you got?
Another one is, do you have a favorite container for saving all your fiber caps at the IO or work end without spilling or someone using it as a trash can?
Yeah, that's a really good question. Who it made me think of is you remember, Tony, you remember John Sharon's cap trap
Yeah.
that he made? I don't think he's making them anymore. Honestly, what I typically use is, I was going to say film canister. That's showing my age. Do I have a favorite one? Yeah. My favorite ones are, if you go to Home Depot, Lowe's, Menards, whatever you got, they're these little clear canisters that have rubber bottom and rubber top. And when you squeeze the rubber top, the opening comes open. You squeeze it, it opens, and then when you let go of it, it closes itself. I wish I could show it, but those are my favorites. And then what I do is I just, put a safety or, little piece of trick line or something to it and tie it to the panel. Those typically don't get used as trash cans, and they're big enough. They come in several different sizes. So that's what I use, is those little containers. I don't know the brand name of them, but man, I got a lot of them. They're any hardware store, big box store, they'll have them, and they're great for fiber caps. Good question. I like it. Usable day-to-day kind of stuff, right? What else you got?
And then this last question, going on selling, but do you have like a basic fiber connection adapter kit for sale? Mix of patch cables. He's asking like LC to M.
Yeah.
Sam Tom, those type of.
Yeah, I'll tell you what. You've got my info. If you don't, we could put it back up there on the screen. But if you just send me an email or whatever, just get a hold of me however you want. There's also my website, has a contact us. Just say, hey, I'm looking for a fiber patch cable kit. We'll definitely get you one. And they're not very expensive. Like I said, they're 10, maybe $12 a cable. Some cables get a little more expensive, like your multi-mode ones, but let's talk offline and we'll definitely get you set up with a kit that'll help you handle any scenario for a pretty good price. All right, is that the end of the questions for now?
Yep.
Okay, cool. Thanks everybody. I love the facts that you're asking questions is it's a good sign. All right, SMPTE connectors. These are the ones that are kind of taking over the world as far as cameras go. SMPTE connectors are, they're good and bad. They are, if you can see look at the image on the right. I would call that the male connector on the right. You see the two ferrules sticking out of there. They're white and they're right underneath the red tab. The ferrules are what carry the fiber. The rest of the connectors in there are copper. So now I would direct your view over to the female side of it on the left. You'll see the other four, there's 6 openings total, okay? The two with the silver sleeves on them that are left and right and fixed more horizontally, those two are the fiber connections, and those are alignment sleeves that they're plugged into there. The other 4 are copper. They are 16 gauge and 22 gauge copper wires inside of the SMPTE. So the SMPTE is what's called a hybrid connector. They travel tally and comms typically down the copper on a SMPTE camera cable. All the data and video go down the fiber. They are definitely the most popular high def fiber cable out there. I oppose that, but that's true. They do make them with and without copper, but you don't see them very often. One of the big bummers about SMPTE is you can tell the military didn't make these things because you need special. They got their own special tools to clean SMPTE. They can't be like the rest of the kids. You got to have a very special tool. I'm going to back up just a couple slides to show you that ferrule inside the male connector on the right. If you guys remember, the Sam Tom and Sam Charlie connectors, those were 2.5 millimeters. The Larry Charlie, the little LC connector, loosened connector, that was 1.25 millimeters. So what do you think SMPTE did? You think they stayed with the standards? You're all shaking your head. No, I can tell. No, they had to be 2 millimeters. They had to split the difference. They're 2 millimeters wide. So you need different tools and different cleaning devices to handle SMPTE, which makes me dislike them. For those of you out here who run into this, one thing I'll tell you is that when you're dealing with these cables, if you're just a camera guy and audio guy, utility, V1, really the only thing you should be doing to these cables is clicking them out or using a swab to clean them. If it involves disassembling the connector in any way, shape, or form, you should be really hesitant to do that because that's when they break. We do a lot of repairs on these cables and we ask a lot of questions. We find out that a lot of times there are breaks happening when people are trying to pull off those little alignment sleeves that I talked about, those little silver sleeves on the left-hand female cable. Those sleeves, they have an extraction tool. You thread it onto there and you pull it out. And you got to use quite a bit of force. What happens is a lot of times people forget to put them back in, and then you plug them in, and then they can get out of alignment and break. So unless you're, a fiber tech or someone who's just comfortable, have done it before, yeah, go ahead. But for the most part, you want a clicker. And in the slides here, we'll show you which clicker and which swabs to use. And yeah, they're similar in size to a triax. Another big thing with these cables is a lot of them come with a rubber dust cap on the top. Rubber dust caps are good for absorbing shock, right? When you drop them, they hit the ground, they absorb all the shock. That's good, but they leave a lot of residue. If you feel to the touch, they feel kind of like a tire tread. So you might clean these cables sitting at the truck or sitting at the video village, and you pre-clean them thinking, yeah, I'm gonna be proactive, clean them. Well, as soon as you clean them and then put the cap back on, there's a good chance you just got more residue on them after cleaning them. That's why we always say clean as you connect. Clean right before you plug them in. Don't clean them and then put the caps back on. So just another tip about these cables. Oh, here's one other thing. They get run backwards a lot. Tony, were you with us? And weren't you with us when we ran into Charlotte, North Carolina for the DNC? And
I was not with you guys.
okay, we went to the arena where the Charlotte Hornets played to do the Democratic National Convention 2012. And we started setup during the day. I was there with another friend of mine, Judd Williams, so those of you who know him. And Judd and I were building cameras, go to plug into the wall, and we were like, uh-oh, these SMPTE cameras don't plug in because the installers ran the entire arena backwards. So that is another big thing with these cables. I can hear a couple heads bouncing up and down out there. Really easy to run these things backwards, so much so that they actually printed on a lot of the side of the cable. It says 2cam with an arrow on the side of these cables. That's how bad it got that the manufacturers changed their assembly process and included a 2cam arrow on them. So it's the same old to send the ladies to the cameramen. That's usually the way we remember it. There's another more vulgar saying, but we'll skip that for now. That's a really good way to remember it. All right. Next up, opticalcon connector. These I like a lot better than SMPTE, but they're just not as prevalent. Opticalcon, or we call them opticon for short, these were developed by the military, and you'll see why shortly here. Opticalcon, they got a push-pull connection. They are hybrid. These you will most often see with power, but it's pretty common to see them without power too. A lot of audio guys use these, and trucks interconnect using these too sometimes. One of the many advantages they have over SMPTE is you'll see the bullet point says duo or quad. That's actually a little misleading. They come in, you can get them in 6, in 8, in 12, just depends on who the manufacturer, what they're willing to do for you. Duo or quad are by far the most popular and most common, but you're not limited because they use that tiny little 1.25 ferrule inside there. If you're able to look inside one of these things, you would see that's a little tiny connector, and it's hermaphroditic. So you can't run it backwards like our good friends in Charlotte, North Carolina did. They were there for like 24 hours straight fixing all that. It was kind of funny. You can't run it backwards. It does mean you need a barrel. Barrels are a little spendy, but it's hermaphroditic, meaning there's no male female. You can't run it backwards. It is also similar to triax camera cable in size. Great thing about these two is this little door that opens. They actually won an award. They have a dust flap inside of them. So if you're looking at the connector on the left there, you see the blue inside the outside housing, the little blue. When you go to connect it, that blue plastic piece pushes in and a little dust flap door raises up on a spring. That is an automatic dust door that protects the connectors, which is a wonderful thing. They also thread apart much like an XLR cable. When you want to clean them, you would looking at this connector, you'd be like, oh my God, I need a special tool. Well, you really don't. All you have to do is break it open like you would an XLR connector, and they screw right off, and it reveals the tips. The tips are right there, and you can clean them with a very simple cleaning tool that everybody should have. Again, military thinks like that. They don't want you digging for that one special tool. They want it to be a very common tool. You'll see them a lot. Like I said, audio guys like to use these. AV productions, they'll run them from front to back the house. Trucks interconnect with them, and some studios use them too. So I'm a big fan of these. And Neutrik makes them. I'm sure a lot of you are familiar with Neutrik. They make them. There's also a company out in California named QPC that makes a little bit different version from them. So they're not the only ones making them. Great cables. I like them. Moving on. Won't spend too much time on this one. I'm sure some of you might have seen this one, but most of you probably haven't. I call it a military timber con. Some people call it different, Type F. These are great for, I would say, Golf Channel and racing venues that have gigantic footprints of fields of play, like a golf or a racing event. Satellite trucks also use them. Again, a military design. Easy to clean too. You'll see the connectors sticking out from there. They're tiny little LCs as well, Larry Charlie's, 1.25 ferrule. There's a thumb screw at the top center of it. You get a little tweaker, you can undo that thumb screw and it removes the whole faceplate. And now you can get at them fairly easily to clean them. And they're incredibly strong, 400-pound strain relief. And you could probably pound a nail in with them too. They're incredibly robust. They're kind of bomb-proof, these things. It's not much you're going to do with them other than you might take the faceplate off, clean and put the faceplate back on. Anything other than that, you're handing it back to the engineer in charge, whoever that might be. Again, nice thing is no special tools. It's an LC ferrule, so you can use LC cleaning tools. Tony, I want to stop there. Any other questions I should pause down for?
There's a few questions. And a question is, here in Europe, we also use MT-RJ connectors and E2000 connectors, and he wants to know if we use those in the States.
No, I've definitely, if you look on the side of some of our cleaning devices, you'll see those cables listed, but we have not, we're barely seeing, what are they, MTP or MPO connectors. We don't use them much in our industry. At least I haven't. If there's anybody out there who has, feel free to speak up. But we have not seen a lot of them. I know they're very popular for their density. There are also, some of them are incredibly difficult to terminate. So when you break them, it can be a problem, but they come with a great advantage of incredibly high density for some of those connectors. But yeah, I wish I could give you more on those, but that's over here. We just do not see that out in the fields we're working on, even in the installations Tony and I work on. We do not see too much of them. What else you got, Tony?
They want to know if there are SMPTE turnarounds.
Everybody has that question. Really, you're not going to find them. You're not going to Google them and find them. They're not very common at all. But we do know. Again, I go back to the name I mentioned earlier. Our buddy John Sharon. John Sharon does make his own custom box, which is a genius little box he created. It is a turnaround, and you can do a lot of testing with this little box that John created. If anybody's interested, again, you know how to get a hold of me. Let me know. John is he manufactures these things. He's a wizard, and he grew up in the research and development side of this industry. Then later in life came to the freelance broadcast side of it. They do make them. They're really hard to find, and it's a great question. I get it every single class. They should make more of them. All right, Tom, what else you got?
They want to know if a SMPTE connector is used the same used for Digico opticor connections.
Say that again. You're getting a little low
It
on.
sounds like you're way off mic there.
Yep, sorry, I was off mic. They want to know if a SMPTE connector was the same used for Digico opticor connections, and
No.
I can say that is a no. They're different connections.
Yes, Digico and Opticor use HMA connectors, which are hermaphroditic expanded beam connectors.
That's one of the real popular ones, the expanded beam. I can honestly say I've worked Digico. They will put anything on there you want. They'll do Sam Tom. They'll do Opticon. The expanded beam is really, really popular. If anybody's ever worked with them, you know why. They've got the little orbs on the inside of them that literally expand the beam, making it harder for it to lose signal by just a fleck of dust. Expanded beams are also popular with some colleges too, because it's harder for the students to break them, but they're awfully expensive to fix too and expensive to buy. But yeah, Digico, they have a host of cables you can use. I think the favorites are what we heard. Was that you, Dave, who said that? Wish I could see you.
It
That
was
was
Mac.
actually Mac.
Mac,
Yeah.
That's probably their most popular is what Mac was talking about there.
Yeah, it's an extremely robust connector as well. But yes, tray expensive.
Yeah, for a good reason, right? All right, what else you got, Tony?
And I will just get this last one in here. Do you have a lot of problems with power and SMPTE cables?
Do we have problems with power? No, we don't have a lot of problems with power. The big problem when you're using a SMPTE cable is usually the biggest problem you run into is the venue that you're working in. A lot of venues don't have SMPTE in-house, but they do have single strand, ST fiber cable plugins. So what you end up doing is using what we call a shed box, a SMPTE hybrid elimination device. It's a fancy word for you're powering your camera remotely. So you put a box out at the camera. The box brings power into the camera and the lens. Everything powers off of that box. It plugs into the wall off 110 volt power. Then the back of the camera, you'll take SMPTE out of the back of the camera, SMPTE into the shed box, and then the shed box converts the fiber to single strand, like ST is the most common. They'll convert it to ST, then you plug the ST into the wall, and then it travels to the venue, back down to the truck, plugs in, and plugs into the truck. So long answer to an easy question, but yeah, typically we don't have a lot of power issues with those. They're pretty darn reliable as it comes to power. And if you do have power issues, it's usually not typically the cables you're working with or the cameras. A lot of times it's something got beat up inside the venue, inside the junction boxes or the IO panels. All right, anything else for now, Tone, or can we keep cruising?
I would start cruising.
All right. Types of cables. Here we go. We'll get a little more specific. This is another one of those parts where I want to make you guys aware of what's out there and what you should and shouldn't be using, and as well as let people know when you see the wrong thing. Cable types. The most common one that we use and you want to see is TAC fiber, tactical fiber optic cable assembly. That's a military term. Everybody calls it TAC fiber. That's the toughest stuff out there. It has the highest crush, bend tolerance, temperature tolerance. I've seen it run over by forklifts. I've actually had one hit by a drag car. There was fire and it only lost one of the 12 channels. It's pretty impressive stuff. Tactical is what you want to see. Look on the side of the cable. Like I said before, always look on the side of the cable, whatever you're dealing with. It's a really good way to kind of educate yourself and be aware of what you're working with. Then we go down to indoor outdoor fiber. Indoor outdoor is meant for permanent installation. It's usually less flexible, but a lot of companies are starting to fake their way through it. TAC fiber is the most expensive, and everybody's always looking for an edge, right? So what they're doing is they're making the indoor outdoor fiber and even the distribution fiber, both of which are meant for permanent installation. They're making it and trying to morph it into a field cable because that stuff is way more affordable. Indoor outdoor, it'll say it on the side of the cable. Distribution, it'll say it on the side of the cable. If it says it on the side of the cable, it's just good to let people know that you know what it is. Again, you don't have to refuse to run it, but it should say tactical. It should say either military tactical, broadcast tactical, or just tactical. Okay. And we'll go through these slides here, show you a little more. Hybrid fiber cable just means that it has copper and fiber inside of it. And then patch and adapter cables, that's what we were talking about earlier, just a little short jumper / adapter cables that we use. So let's run through them. Here's what a typical kind of TAC cable looks like. It's got a TAC 12. It's got a 12 channel fan out. Usually there's a safe sock over the top of this one. And when we talk about TAC fiber, we're really talking about jacket, right? We're not talking about the connectors, but this is how it appears to, hey, look at that. Can everybody see what Tony has there? There you go. Pull the sock back and let them see. I know I've got all that stuff sitting here too, but my stupid camera.
That's why we have assistants, dude. It's all good.
I'm telling you, Tony's the best. Look at him go. Pro. That is a beautiful tactical fiber cable. Okay. You got the side of the jacket there, Tony. I know it'll be hard for us to read it, but go back to the black part of the jacket. Every 2 feet, you're going to see writing on there. And, hey, look at that. That's pretty good. Drop it down. There you go. Bend insensitive. What does that say? Bend insensitive. Fiber optic, broadcast fiber optic cable. Okay, this is one of, and okay, hold it. Give me, yep, distribution. See that word right there? Distribution. This is one of those cables where it's kind of impressive what they've done, but they're cheating. When it says distribution, it's not tactical cable. And I've had these arguments with major manufacturers before, and but yet you go back to the scientific and research side of this, and they will not budge. When they're selling cable that says distribution on it, they're making it cheaper. They're selling it to you. You think you're saving something. They're not as good. The strength, the yarn inside of them. Thank you, Tony. The yarn inside the cable is not as good. The jacket, it's not probably not as heat resistant, and they'll swear up and down that it is. I until I get the people who actually work in the labs to agree with them, I won't believe them. But listen, that stuff that Tony held up, it'll still take a beating. So it's not like you're working with something that's going to fall apart in your hands. But if it doesn't say tack, it's not tack. So I'm glad you had that one on you. That's a good demonstration. And we kind of went over a lot of this stuff. Military, aerospace, broadcast, absolutely all those applications. Easy to clean and troubleshoot. That's more talking to the connectors. It's a little different. Most common in our world, yeah. Let's hope so. Let's hope it stays that way. Moving on to the next one, indoor-outdoor cable. This is probably, this along the distribution, they're the most commonly substituted. Indoor-outdoor cable is meant to either go underground or go in a conduit or in a cable tray and stay there. A lot of it looks exactly like tack. Even sometimes it'll feel like it, but it's not as durable. You can't bend this stuff like you can tack. If it's classified indoor-outdoor, then it does not have the same crush, bend, and heat tolerances that tack cable does. It's perfect for what it's built for. If you gotta do an install and it's gotta endure running maybe outside or underground, that's what it's meant for. It's exactly what it's there for. Again, read the side of the jacket and you'll see. Next is OFNP, optical fiber non-plenum distribution. This is what your little patch cables are made of oftentimes. And then if you look up, next time you're in a venue, you look up in the cable tray, you'll see a lot of these yellow PVC plastic coated cables up there. These are, again, great for, Tony and I have probably installed enough of this cable to circumference the planet. We've gone through tens of thousands of feet of this cable. It's great for installation. If you see it in the field, say something, because it's not meant to be run over by a forklift or hit by a drag car like mine is. Really cheap. My gosh, I can get it really, really cheap. The connectors are far more expensive than the cable. That's why if any of you guys are ever going to do an install, always get, if you need 3 connections, run a 12. If you need 12, run a 24, because the price difference is so small to buy the cable. And another good tip for installation is always run more than you need, and you only have to terminate, if you need 6, terminate 12, coil up the other 12 behind the wall for later termination. Tony and I have proven that method successfully many times in these different arenas we work in. We always make them run more than they need. We don't have to terminate them right away. We just terminate what we need for now. And then later when they call you 2 years and say, hey, we need more fiber, we say, it's already done. We just have to put the ends on it. So that's about it on that stuff. Hybrid fiber, going back to that a little bit, the most common hybrid fiber cables we're going to see in our world are like opticalcon, SMPTE fiber. That just, again, that means there is conductive in them as well as fiber optic glass in them. That's what hybrid means. They are, yeah, SMPTE. The termination is really complicated if you have to cut an end off and put them on, but in the install world, it's become really simple. You simply put really common, like those Unicam connectors, you put connectors on the cable, and then in the junction box or the IO panel, you put these modules in place, and you simply plug the camera cable into the module after you've terminated them with a simple connector. That's how they've changed in recent years, and it's great. We just put a bunch of SMPTE in a year or so ago into the Excel Energy Center, and that's the system we used, where we didn't have to go through to terminate a real SMPTE connector. You got to go through a lot. You got to buy a lot of gear and go through a lot of classes. However, if you can snap a Unicam connector on the end and plug it into the back of a module that turns out SMPTE on the front side, that's what you want to be looking at. So for anybody considering install, definitely let me know about that, and I'll send you the links to that kind of stuff. Now here's another, like I said, you can adapt any fiber cable into any other fiber cable. If you ever think you're stuck, you're not. You may need some time to get the cable, but they will convert anything to anything. And now we do have to preface that by saying, single mode, multi-mode. You can get adapters that will take you from single mode to multi-mode, but they are a box, okay? It's not a cable. This SMPTE whip is a really common one. It's going to take I was talking earlier about the shed boxes. So these are great for testing too, these SMPTE whips where you've got SMPTE on one end, and this happens to be ST, Sam Tom on the other. And there's Opticon one, they make Opticon whips. Basically, whatever cables you can think of, they'll make them. Some are a lot more common and a lot more affordable than others. I love having these cables with me specifically for testing. Key example, say we're working on a Digico board, right? And it's got Opticon coming out the back. Well, I don't own a tester that will input Opticon. Those are pretty hard to come by. But I own a ton of testers that will take ST. So I can come right out of the back of the box, plug that ST Sam Tom connector into my meter and tell what's happening right away. So not only are they great to make an adaptation happen when you need it in a pinch, but they're great for testing and getting, sniffing out the problems quickly. Let me stop there for just a moment, Tony. Anything else on the questions?
Yeah, we got quite a few questions here.
Okay, go ahead.
This one pops up. Does NEC transition rules apply to fiber when going from outside the building to inside?
Say that again. What NEC transition rules?
Yes, NEC transition rules apply to fiber when going from.
Yeah, so it's going to be a little bit different. A lot of times it's a municipality kind of thing. I think one of the best moves we ever did when Tony and I first got started installing, we called the city. We called the inspectors in the city, told them what we were doing. And instead of being, going into jerk inspector mode, they were the most helpful people you could imagine. There are a ton of standards that are just kind of known throughout the industry. And then there's what your inspector will sign off on. Okay. So that question, that's kind of a wormhole. I don't know if I want to travel too far down, but you could definitely give me a call or email and we could go through it in really specific detail for you. But there's a great website I want to turn everybody on to if you're really looking to get that deep into the fiber wormhole. It's called the FOA.org, Fiber Optic Association, FOA.org. The FOA will talk about stuff like that. It'll talk about the different types of polishes, angle polishers, universal polish. It'll give you all the information you want to know. It's not a pretty website, but man, there's great information on there. So I would say for that question, why don't you catch me offline and we could go deeper into it if you like. What do you got next, Tone?
Let's see here. There's quite a few questions. So I'm just going through these.
Good.
Where it's question is, if for installing fiber, there's almost no reason not to just run 24 strands, and I can just answer that one, Jesse. Is it really just comes down to cost? If the client wants to pay for 12 strands, then it's 12 strands. I mean, it's kind of it really comes down to cost and what their budget is.
Yeah, it's kind of a case by case basis, right? I'll give you an example, Tony. Like there are positions in venues. I'm going to use a hockey arena, for example. There's positions all over that venue. Let's take the main camera platform, the game deck on a hockey arena, right? That's going to be one of the highest traffic areas for connecting in and out. They're going to put sets there for pre and post game shows. They're going to have cameras there, monitors. It's going to be a really high traffic area. If you think there's any chance whatsoever that the destination you're running the fiber to is going to be high traffic, always go overboard. 24 was probably extreme, but I would say start with a 12, man. I wouldn't go lower than a 12. But yeah, if you think it has any chance of becoming a higher traffic area, you're doing your clients a really good service by installing more than they need. Yeah, go ahead, Tom.
This question is, what is HDNet fiber? And I think he's
Well, HDNet is a network, so you've probably seen that in some of the venues you've worked in. It's kind of funny because Tony and I have that at our at the XL2. We've seen it there. That's fiber just like this is. It just happened to be installed by HDNet, which used to be a network. And correct me if I'm wrong, right, Tony? Is that the Mark Cuban network that used to exist?
It was.
It was, yeah.
I mean, he owned that network, yes.
Yeah, and it doesn't exist anymore. So they simply put, and they went all over the country doing that. They put.
I think he's more referencing what the connection is and what type of connection.
Oh well, I don't know. They probably did different connections in different cities. Ours was, there was some ST. Oh, they did use a what is that stupid thing, Tony? They used a it's escaping me now.
I can't remember.
Not
It's
an F type, but a
we're talking
D sub.
many
It's
years ago that I can't remember now.
Here, I'll tell you what we did with that fiber. Whoever's what's the name of the person to show you? Who asked the question?
Gary Weiss.
Gary, here's what we did with that. We opened up the panel, we chopped off, we threw that connector in the garbage, and we put ST connectors on there, Sam Tom, ones we could use. So that would be my best advice, is rather than trying to find some expensive, obscure connector and adapter that's going to get lost, people won't know where it is, I would go back there, chop it off, and especially if it's an indoor arena, just put Unicam connectors on the back of that bulkhead and terminate it with ST Sam Tom, by far and away the most common. But read the side of the jacket before you do it, so you know that it's single mode versus multi-mode. But we've done that at Miller Park. I think we did that. We did that at the Metrodome in Minneapolis. We just chopped it off and made our own connections, which was much more useful. So, but the glass is still good. So,
is there a plenum rating for fiber?
Oh, sure. Yeah. Plenum, just like any other cable, plenum means fire resistant versus there's riser rated and plenum rated. Yes, you just, the rules, the basic rule of thumb is, if you're running a cable through a non-ventilated area, let's say up above false ceiling, anywhere that's non-ventilated, they definitely want you to use plenum rated. If it's running through a conduit, you can use riser cable, which isn't plenum rated, but we just basically, we do mostly all plenum. The background on that is kind of terrible and interesting. In 1999, there was, I believe it was 99, there was a hotel fire in Vegas, and a lot of people died, unfortunately. And the result of the report was that a lot of them died from fumes, and they decided that it was toxic fumes given off by the jackets of the fiber optic cables put in the hotel. After that, they went way, I'm not going to call it an overcorrection, but they went pretty hardcore on what could be put in stadiums and what couldn't. My first install was 2000, and we did another one in 2001. So when I was talking to the inspectors, all of them were very aware of that problem in Vegas. And so they told me, look, the safest thing is just to do all plenum, but you have to know to ask for that. That's another one of those things. If you're doing install and you need any advice, don't be afraid to give me a call. So, all right, what else?
We'll just do this last connection and then we can move on.
Mm-hmm.
Can you just explain the difference between opticalcon and opticon?
There is no difference. Opticalcon and opticon. Opticon is just short. It's just short for opticalcon. There's no difference at all. It's just vernacular is all that is. But it'll come. You can get it in single mode, in multi mode. You could get it with 2 connectors, 2 fibers, 4 fibers, 6, 8, 12. It comes in a lot of different varieties, but the term opticalcon, we just shorten it up and call it opticon. All right. What else? Is that it for now, you said?
Yeah.
Okay, cool. All right, now we're going to talk about patch cables. Patch cables, they seem simple, but they're not. It's really easy to get them screwed up and get the wrong thing in the wrong place. first thing, and I should have thrown an aqua one in here too, is the color of the patch cable. The color gives away what kind of which mode it is. Yellow is single mode, orange is multi-mode, OS2 or OS1, and then aqua, there it is. Aqua is also multi-mode, the newer form of multi-mode, which is 50 micron opening, if you remember from the earlier slide. There's 4 criteria to use when you're identifying or asking someone to get you a patch cable or buying it. You want to name 4 different criteria when you're asking. Number 1, which mode? Okay, single mode, great. How many strands? Simplex or duplex? 1 or 2 strand. Okay, you want a single mode duplex. All right, what type of connectors do you want on it? And anytime we're asking for them, we say both ends. Don't just say, yeah, give me a duplex single mode ST patch cable. Okay, ST to what? You want to name both ends. So is it Sam Tom to Sam Tom, or is it Sam Tom to Larry Charlie, so on and so forth. And then you want to say how long. Oh, what do you got? There's a good one. All right. So what we have there is a simplex single mode Sam Tom to Sam Tom, and it looks to be about 2 meters long with Tony's electrical tape on there. Thank you, Tony. What else you got? Any others? Okay, so that's a Sam Tom to LC, Larry Charlie simplex. It looks to be about 1 meter long. What else you got? He's digging through the goodie bag.
That's
Hey,
all
that's
I
good.
got because I have no multi-modes in my tech kit. I don't
That's-
use multi-mode ever, really.
I'm glad you were able to show that. So that's what you want to know. I want to empower you guys to be able to go around and talk about this stuff and show people the knowledge you gained here. It's what seems simple isn't, and this kind of miscommunication can really screw up your show. If you don't know what to ask for, if somebody just says, "Hey, go get me a fiber patch cable," okay. Well, no, you got to find out the specifics of it. It might seem like a simple thing, but it can really make the difference between a good day and a bad day. So, any questions on patch cables there, Tony? I kind of blew through that real quick.
Nope.
Okay, moving on. Handling fiber. All right, it can take a beating, but let's not beat it up. Let's be nice to the fiber. Don't kink, twist, strain, or pinch it. Yeah, you know, the big thing is we've all done it before. You take a copper cable like an XLR that's all wound up and it's got a bunch of curls in it. So what do? You hold it up about shoulder height and you start twisting it, kind of do the cowboy thing to unravel all the twists. Yeah, don't do that to fiber, especially like a SMPTE cable, a hybrid cable. If you do that to a SMPTE or an opticon cable, what you're doing when you cowboy spin it like that is you're binding the copper inside of the cable against the fiber inside of the cable and you're crunching it. Some of the newer stuff is a little better held up against that, but just don't do it because that's a really common way for it to break. We see that quite a bit when we do our repairs. And when I say kink, twist, strain, or pinch, okay, here's a real simple scenario most of you have seen. You start your day running running a fiber cable. You plug it into the side of the truck or into the junction box. And if you don't put a strain relief on there, well, remember, we're trying to line up, if it's single mode, a little 9 micron laser to another input of 9 micron laser. We are trying to line up 2 microscopic beams to each other. If there's strain on that cable, you're causing loss in the signal. And now you combine that with, you run it over to, you run it up a ramp and then over a handrail or over a truss. Well, if you run it over a truss and you tie a piece of trick line to the fiber, then you tie it to the truss, well, what happens if there's pinch? If you got a single tie spot on there, well, it's gonna kink right there. So whenever I tie up fiber optic cable, if it's gonna get some kind of strain on it, I do 2 points. I take a single piece of rope, I put a clove hitch, hopefully, on the on one side of the fiber cable, run it up and over the railing or through the truss or whatever you're dealing with, and then tie the other end to the fiber cable as well. If you're gonna tie it off, tie the fiber in 2 spots. If you think there's going to be some strain, don't tie it in 1 spot because you could create a real kink there. And then where you run it, make sure it's not going to get under some bleachers, get stepped on too much. It's not going to hurt it to get stepped on, but over and over again, just keep it as safe and out of path of traffic as much as you are able. Because now you think about when you're handling fiber, it's probably got a little bit of dirt on it. That's going to cause a little bit of loss of signal. Now, if somebody plugged it in one end to the other and it's not strain relief, you just lost a couple more points of signal. Now it's getting kinked or pinched or strained around a corner or hanging off a truss. Those are the most common reasons why your fiber isn't working. It's usually just the methods you use to install it and run it and lay it in the venue you're working in. Protect the strands and cap the connectors. Yeah, put the caps on the connectors. It helps. It keeps them cleaner, or it keeps them from, shock absorption, keeps them from getting dropped and broken. The strands get twisted up a lot. So think about that when you're pulling them on and off. Don't let the strands get all twisted on themselves on either end of the cable. And don't handle it like copper. Like I said, don't cowboy it around like that. Always using cable trays or runner rugs. And this is the thing, guys, if you're EIC with your truck or your tech manager or whoever your engineer in charge, they see you not doing these things, they're probably going to yell at you. And I'm sure, like me, most of you have been yelled at. So just get used to doing this stuff. And all cables are not created equally. As we discussed, read the side of the cable and you can tell. So, you run a cable and you didn't read the side of it. It happens to be indoor, outdoor. It gets run over because you didn't put it under some kind of yellow jacket or a rug, and it gets broken. Well, now you're standing there as the bad guy. So yeah, just protect it a little more than you would copper. I think you get this. I'll get off my soapbox. I'm done yelling. All right, testing and cleaning tools. I'll stop there for a second, Tony. Any other questions we want to address yet?
No, you can keep going. Well, I mean, yeah, I guess I'll answer this one. Can you easily adapt a 50 micron to a 62.5 micron cables? Because he says he sees most AV equipment using multi-mode 50, but I have 62.5 installed in walls. Can you directly plug them in?
It's funny. You can. Yeah, it depends on the length and it depends on the boxes, but a lot of them will tolerate it. The best thing I'll tell you is just try it, and a lot of times it will work. It shouldn't work. It's not supposed to, but you can. To answer your other question, to easily to adapt it, yeah, you can actually. They make boxes that are converters. You plug the 50 into one side and it spits out 62.5 the other side, or vice versa. So they do make those boxes that convert, and they're not that expensive. So I would always say, yeah, because what you're doing is, it's just like wiring. You're taking one gauge of wire down to another gauge. Will it work? Yeah, for a while. But now imagine all those other things I just ran through. If it gets a little dirty, if it gets kinked, if there's not strain relief on it, well, there's cable loss, there's signal loss happening for a lot of different reasons there. So when you start your day by getting the wrong size opening, 50 versus 62.5, you're already kind of starting from behind. You only have so much budget of loss. When you talk installation, they talk about budget. What's your loss budget? Well, when we're talking about just getting a show hooked up, if you're starting off in that scenario, you're already losing a little bit of signal. It might get you through, but eventually it's going to bite you. So I would definitely suggest looking into those converters. And again, if you need help, let me know. I can get you to them. Good question. Really good question. All right. Anything else before I move on?
They want to know, can you use a multi-mode patch cable as a jumper and a pinch over a single mode?
You can. I've seen it work. I've done it myself. You can in a pinch. Yes. The number one thing is just to make sure you pre-clean everything. But yeah, it will work in a pinch. I've even opened boxes before that are like telecast multiplex boxes. I've opened a couple boxes in the past from a certain vendor who a lot of people recognize that I won't say. You open up the box to do some fixing and tweaking, like reseating circuit boards and such, and you'll find the little tiny patch cables inside of there sometimes are multi-mode, even though it's a single mode box. So yeah, it'll work in a pinch. It'll get you by for a little while. It kind of depends on the signal and what kind of loss is happening before and after. But yeah, I've seen it work and I've done it myself.
A lot less likely to work the other way, using a single mode patch cord for multi-mode.
Absolutely.
There's such a small hole for all the light that's coming out of that multi-mode to get down.
Absolutely. Yeah, really good point. Going the other way, not so much, but yeah. I mean, I always teach best practices and tell you guys what exactly you should do, but we all know that in the heat of the moment in a lot of shows, we don't always have the exact tools in front of us and all the options on the table. So it's good to talk about what are some of the MacGyver fixes, right? What are some of the tricks the pros know? Well, that's one of them, and it's a good question. All right, anything else, Stone, or should we go through testing and cleaning?
Go through testing and cleaning. There'll
All
be
right.
a few there after that, I'm sure.
So what you're looking at here is a magnified image of the end face of a fiber optic connector. So maybe this is a SAM-TOM ST. When you blow up the image, this is what you see. Let me just see the next, this one I like to use a little better. There's a couple devices I really like to tell people to use if you're, especially if you're just, maybe you're a utility looking to move up, maybe you're a camera guy sick of running back to the truck, maybe you're an audio guy sick of running back to your A1 to get these devices. You want to have some of your own cleaning stuff. One of the most important things you can have is a scope, handheld microscope. They're like $110 is all. We sell them. You can see them online. Oh, Tony's got his. There it is, 200. He's even got his name on it. It's got a little thumb. Just show them the little thumb wheel there and the button, push button. There's the diopter. You focus it in. There's the on off right there. You stick the fiber in the other end. Show them the end you put the fiber in and hold it there for a minute. That is a 2.5 millimeter receptacle. When you buy this device, it comes with a 1.25 as well. It threads on and off the end of there. And then the other, you see the other thumb wheel there, that's for the batteries. The great thing about a scope is you can see what's going on with the different cleaning instruments you're using. You'll find that certain instruments work better in certain applications. It might not necessarily make sense, but you can prove it by having a scope, because to the naked eye, you obviously can't see anything. There's the adapter at 1.25 that comes with it. Nice, thanks, Tony. But yeah, you go through and clean stuff, especially when you're starting out. You go through, you swab it, you click it, you run it on the fiber cassette, and then look at it again to make sure you got it. Because what you'll quickly realize is what you think is happening isn't always happening. Maybe you pulled out a cassette to clean it with that, had a little dirt, you had it in your pocket, you forgot to advance it to a clean swatch, and you put more dirt on it than you took off. The only way you would know that is looking through a scope. That scope is a great product to have. It, like I said, it really helps you learn quick. Number one thing I'll tell you though, safety-wise, is make sure there's no laser coming down the other end of that line. Just like you wouldn't grab a wire if the electricity was turned on, always make darn good and sure that there's no laser sending down that light before you hook up that scope and blast yourself. Give yourself LASIK on site. It's not going to blind you, but it's not going to be good, and it will hurt. So when you can magnify the image, you get to talk about what this thing looks like. That upper left one with the red outline, that's the best. That's like a perfect connector right there. The little white dot in the middle, that's the glass. It says core. Okay, that's the middle of the middle of the middle. That's the glass. If everything else is dirty, kind of like the one right next to it, the connector with dust, if everything else is dirty, oh, there you go. Yep, that's how you put it in there. And you turn it around, put it on your eye like you would kind of like a microscope, because it is a microscope. Put it in there and you're in business. You focus it in, and then if it's still dirty, you take it out, you clean it, try it again, keep going. Try a couple of, breathe, don't lick it, Tony. See, I have to stop him from doing things like that. He gets a little crazy. But I do fog it. Before I clean them, I fog them with my breath, because what is that ferrule made out of again? It's ceramic, it's glass. So you fog it and then you figure eight it. You do a figure eight. Why do you do a figure eight? Because that's how they're built. When they are polished, they are figure eighted on a machine or by hand. So that's best cleaning practices. You figure eight it on a lint-free cleaning device. And to be honest, here's another kind of a fiber hack. That's the number one right there. So Tony's going to fog it, and then he's going to figure eight it. Go ahead, Tony. Show him how you fog it. Yeah, but fog. So you're breathe on it. Don't lick it like Tony always does. And then you figure eight it up and down the cloth. That is the number one best way to clean fiber. Cheap, easy, and really effective. And I'll give you another kind of a life hack here. Fiber hack, we'll call it. You can use your blue jeans. The reason you can use your blue jeans is because some of the more expensive fiber cleaners are actually made out of denim. Denim is a really effective cleaning tool. Now, don't use it on the jeans you use to change the oil in your 72 Pinto, but clean part of your jeans, yeah, you can clean it and plug it back in, and it's pretty good results. Next thing we see there, so we know where the core is, a little tiny white dot in the middle. The black stuff surrounding it is actually glue. That's the adhesive that was polished down by the machine. It was polished flush with the surface of the in-face connector. And then on the outside of that glue is the cladding, as we saw early on. And then all the white stuff around it, that's the end face of the connector. This stuff, obviously, this is a 400 times magnified image on a microscope. So being able to see what you're really doing, which is impossible to do by naked eye, is so helpful. Really good examples here of the most common types of problems with your fiber connectors, how they get dirty. The one in the top middle, connector with dust, that's probably the most common that we see. A lot of that is that'll even residues from caps. You got a cap on, you're like, oh, the fiber was capped, I'll just plug it in. Yeah, you might get lucky, but a lot of times the inside of the caps are dirty too. So I always just say clean as you connect, clean what you're plugging into and clean the cable as you connect, and you'll have much better luck. Next to it, micro scratches, fairly common as well. Usually means it was a poorly done job of terminating and polishing these connectors. And you can typically get away with scratches unless the scratch is right through the middle of that white dot. If you got a scratch over the glass, you're probably out of business. Here's what I'll tell you is when you're troubleshooting and you're metering fiber, you think everything looks good. A lot of times go look at the boxes, okay? A lot of the boxes that we end up using, like a truck comes in from out of town and you're using their converter boxes or their shed boxes or their booth box for audio, a million people have touched them and plugged stuff in and out of them before you ever got to it, right? Well, on board most trucks, they'll have a probe, a fiber probe, and if you're testing everything and everything's coming up good, well then look at the box you're plugging into and say, hey, can we, if you know how to use a probe, take it, go use it, or get a video or a EIC up there, have them probe the inputs and outputs on these boxes that go into the booths or the belly bay of the truck for that matter, or the video village, whatever you're working with, fly pack. A lot of times that's the problem, is they get beat up more than anything. The cables, they may switch and use different cables, but the same inputs on those connectors are used over and over again, right? So that's another one that can really spoil your day when you're trying to figure out the problem. We'll keep going down the road there. Connector with oil. Yeah, the oil comes. Here's a really funny thing. I wish in class we always do this demonstration. That little, Tony, put up your camera again and show us the end, the ferrule of that connector you were using. Take the cap off of it, if you would, kind sir. So, and then tilt it so we can see a profile of it. Yeah. So that little plastic thing is a lot tougher than you think. I can take that thing and use it like you would use a pen, and I can carve my name in a wooden table. Okay. And I could clean that thing off and it'll be as good as new. It won't damage it because glass is harder than wood, right? So that ferrule is a lot tougher than you think. You could carve your name into anything as long as it's not harder than glass. However, if you brush it against your skin, you just, while you're trying to plug it in, which happens a lot, you brush it against your skin, you'll get a ton of oil on there. If you ever want to do something really gross and really fun, rub it on your nose and then put it in your microscope, and it's like a petri dish. And that it's gross, but it's a really great illustration of, you brush it against your skin, now it's got all kinds of residue on it that you didn't know about. A lot of times that is what's stopping the signal from working. Really good piece of advice too, that bottom middle one, connector with liquid. You can use chemicals to clean. There's nothing wrong with it as long as you do a dry cleaning afterwards. That cassette that Tony had, always clean with something dry. If you're going to use alcohol, like you see in the next one over, that lower right, connector with alcohol residue, that's because somebody just cleaned with alcohol and then left it. Well, if you clean with a chem wipe or alcohol and then don't do a dry wipe after, that's what you're going to get. And I love that on the side of the bottle, it always says residue free. Liars. We have microscopes, so we can tell these things. Always do a dry clean after a wet clean. A really cool method I saw another guy use, I stole from him, is if you got a large dry swatch of cloth to clean on, just squirt half of the cloth with liquid and leave the other half dry, and then drag it across from wet to dry, wet to dry. That's a really quick, easy, smart way to do it. All right. Any questions here, Tom, before we move on?
Hold on one second. My screen went away. Just some questions. We can go over those questions after this. It's more just on what scope this is and whatnot. You can talk about it at the end.
Great. Okay. Moving on. But yeah, get a scope. If you're really running into fiber a lot, you'll be glad you did. Here's a picture of some other things these are my favorite devices here. I will tell you some things have changed, some prices have come down. On the left, you'll see those orange clickers. number one reason I love these clickers is because they have a replaceable cartridge. That's huge. They're the same price as a lot of the clickers that don't have a replaceable cartridge. And to add on to it, they're good for 750 cleanings. A lot of the other ones are only good for 500 cleanings, and they get thrown away like a guitar pick, you know. These are replaceable. Senko makes them. They're Senko Smart Cleaners. Now Sticklers makes them too, a little more affordable. There are now in the last probably, I don't know, year or so, Amazon has a bunch of stuff out there, and I've bought them to test them. They're kind of crap. They got $20 clickers, right? And they say they're good for 500 cleanings. But what happens is the spring inside of them breaks. These things have a spool. I don't know if you have one with you, Tony. You could show that little window of the spool.
Yeah, unfortunately, I'm
That's okay.
looking
No.
for it and I don't see it.
What these things do is they're flossing. Think of dental floss. It's a silk thread inside these clickers. And when you plunge it, you depress it down, it's advancing the thread across the face of the end face of the connector. And it's also spinning. Not only is it dragging that silk across that connector, it's also spinning. So you click it like 5 or 6 times. Hey, look at that, for the win. See that window right there, that little spool? That's to tell you when you're out. And I think I could speak for a lot of us. We didn't know they were out sometimes. And then you look at the window, but that's what it is right there. Thank you so much, Pete. Yep, it plunges like that. You click it, and see that cap he's got on the end? That's for, so when you pull the cap off, you're cleaning a female, an input. You put the cap on. Now, let me see the side of your blue housing there. Is that what is that, an M20 or is it a IBC now? SC, okay, SC, Sam Charlie. That's good to know. SC, if everybody was paying attention in class, is a 2.5 millimeter ferrule. And now, yeah, smart move. He put on there so people know. Those are the type of connectors it'll clean. That means it's a 2.5 millimeter ferrule. Got a little bit of thread left there. Still good for a while. Those little devils are great. They're very handy.
By the way, they're also really good after dinner.
Through your teeth, huh? I like it. Let's try that. They're good, but I've tried to buy some of the cheaper ones because the orange ones here and the blue one that Pete was showing, they can get up to like 50, 60, 70 bucks, right? Retail. I've bought some of the cheaper ones in the last 6 months off of Amazon, and I'm done with them. I had to try because I want to tell everybody the best thing to do. It's not about markup, it's about getting you guys the right stuff. And the Amazon ones, half of them are breaking. They're good for, 50, 60 clicks, and then they won't retract. They click in and they won't click back, or the thread will just come undone and the springs will break. So I would stay away from the cheap Amazon ones. There is one thing on Amazon I found lately that I would recommend. The yellow cassette Tony showed, it's a Hellerman Titan product. It's a great cleaner. I referenced earlier the denim cleaners. Well, those denim cleaners have come way down. They've come down to be not quite as affordable as the yellow one, but they've come close. They're like 30, 40 bucks now. The yellow ones are about 17 retail, somewhere in there. The denim ones are really, really good cleaners, top of the line. So if you have some questions about products you're looking at, like I said, just get a hold of me. I'll give you the best advice I can. Over to the right, you got a power meter. I think, does that say 512 or 510? I can't tell, but those little devils are so cheap, and I have used them for so long. The one I've had for 6 years. It's beat up and scratched, and it still works great. They're 40, 50 bucks. You can even get them lower, but this is the one I recommend because I've used it for so long. I bought some other cheaper ones. They don't last. So to my knowledge, I'll say this little guy, it's called a TL Tom Larry -510. That's the one. Again, I have them for sale, but just let me know if you want to get them. I think we sell them for like 45 bucks. It's a power meter. So a fantastic way to troubleshoot your fiber. If you're working on a soundboard, I don't care what it is, a rattler, a Fido, fiber's coming out of the side of a truck. If you got problems with some signals, find one that is working if possible. Okay, if it's working, take a little patch cable, plug it into the transmit side that's working, plug the other end into your meter. It'll give you a reading. You have to select the right wavelength. And again, this is something when you guys get into this, let me know. We can go through it with you individually. You select the right wavelength, you'll see the reading. Okay, If it's good on the lower, if you look at that blue button on the lower left of that touchpad on that device, it says reference REF. You can zero it out. Okay. Now you go and test the bad signal. All right. What I'm trying to say is use the boxes that are a part of your production as the test models, because those are the boxes that have to work for you. You could take an individual signal generator that you, just like you got audio signal generators that can generate tone, and you got video that you get a little signal generator that can send a test pattern. Well, fiber optics makes signal generators too. Well, that's great if you can test something, use a signal generator. But at the end of the day, the signal generator isn't a part of the show. The box that you're using is a part of the show. So whenever possible, I like to leave the boxes in place that we're using for the show and put my meter on them with a little patch cable, which is another reason to have multiple patch cables, and see what their launch readings are, see what the numbers are, and compare them and contrast them. And you say you got a stack of FIDO sitting there, or you got a board that has 4 different outputs. One of them's not working. Okay. If there's a cable that's run from the back of a Digico audio board all the way up to the, to on stage, break out the cable before it goes into the receive end or before it goes into the stage box. Turn it into ST, Sam Tom. Plug it into your meter and go right down the line. Clean it first, plug it into your meter, go right down the line. You're going to see most of them are within a point or two of each other. Okay. Then you'll find the bad one. Just like measuring voltage. Voltage, what you start with and what you end with is the number you're looking for. If we were in a class right now, you guys would have all these in your hands and we'd be actually going through it. But I think you can kind of pick up on what I'm saying is that you want to find the good one and make that the baseline for testing. Once you got a good one, see what that output signal is at. Remember that number, save it or reference it, zero the meter out, and then move down the line and see what the other ones are doing. That is the best way to really troubleshoot in the field. Because like I said, you can prove the cable's good by using a signal generator and a meter. Say, okay, great, my cables are good. Well, like I was saying earlier, a lot of times it's the boxes, right? So the best way to tell if the boxes are working is using the method I was just describing. And that's it's a really quick way to get down to figure out what's going on. There are some other meters, higher end stuff, but another great reason to buy a meter like that is it's 40 or 50 bucks, man, and it works. I have really expensive meters that I only bring out for certain occasions. We got stuff that costs thousands of dollars. I don't bring that with on the little, like the everyday baseball or hockey show or the concert or whatever. But if I'm going in to do install, or Tony and I are going to a stadium that we are specifically there to assess out their entire stadium, that's when you bring the big boxes out. So right tool for the right job, and luckily sometimes you can get away with the cheap stuff. And that little guy right there, that I told you the model number, Tom Larry -510. If you're looking for a source, the generator, you would go Tom Larry -512, and you can get those in single mode or multi-mode wavelengths. Let's talk. I'm going to back up just a little bit here. Let's talk quick about wavelengths. Make sure everybody understands. Just simplify it. You remember the Corning video, right? You saw the light bouncing down the tube. The way the wavelength is determined, for those who don't work with, don't interface with wavelengths and frequencies a lot, it's how many times that light bounces in a second. How many times it bounces in a second is what determines the wavelength. So for instance, single mode wavelength that is most common in our world, in the world of broadcast, is 1310, and it is measured units of nanometers. Okay. 1,310 nanometers is what single mode uses. That means it's bouncing 1,310 times in a second down that tube. If you're using a multi-mode source, the most common wavelength for multi-mode is 850. That means it's bouncing only 850 times in a second down that tube. That is how wavelength, and to be honest, a nanometer is a measurement of color. That's how color is determined, is measured in nanometers. Tony, do you happen to have a laser with you? Sorry to put you on the spot, but do you have your little handheld laser? Don't tell me I stole yours either. I know I did. There it is. All right. Yeah, don't shine in the camera. I want to see the labeled above your pointer finger. Can you find where it says 650? I don't know if it'll make it dark enough, but These little lasers are cheap too, a fantastic tool. And oh, there you go. Look at you. Hey, there we go. 25 milliwatt. It doesn't actually show nanometers. Okay. Milliwatt, a lot of you are familiar with that unit of measurement. Some of you may not be. Milliwatt is a measurement of power. Okay. How much power, or in the case of a laser, you could say how much heat the laser is generating. If you're buying one of those lasers, you are going to see one that says 650 nanometers. That is the color of red. And then it's going to have depending on what you want, you can pick which milliwatt. How strong do you want the laser to be is all that means. The quick calculation there is it's 1 milliwatt per kilometer. So if you have a 1 milliwatt laser, in essence, it is meant to shoot 1 kilometer. If you have a 25 milliwatt laser, it is meant to shoot 25 kilometers. Tony went for the big boy. We call it the lightsaber. That one will show up really nice and bright. Even in bright sunlight, you're trying to assess something out, you're sending the light down a line, that 25 milliwatt will really shine bright for you. Whereas a 1 milliwatt will be a lot harder to see. Oh, here we go. Here we go. Look at that. All right, this I can work with this. That's nice. So that's what Tony's doing right now, by the way, is a great example of why we use these lasers. Another fantastic tool to own. They're cheap. You can get one like Tony has there for 30, 40 bucks. They're even cheaper for the smaller ones. There you see light escaping. Great example of light escaping, okay? That laser that Tony has is way more powerful than what's being used in the ones in your equipment, coming out of a Digico board or a Telecast Rattler, Fido. Those are like a half of a milliwatt at most. He's using a 25 milliwatt. But what it does is if you're on one end versus the other, you can identify which line you're on, right? You can also measure this. You can measure this with the right tools. That laser, yeah, you can make it blink. That laser can be measured in your single mode setting on your power tool. So you can leave it up there, Tony. One other thing I want to show everybody in a second. On your power meter, the TL510, if you set the wavelength to 1310, it will measure that. So that's a really cheap fiber optic measuring device. It's not something I would use in a really critical situation, like we're trying to give readings to a building that hired us. I wouldn't use that. But if it's a on the spot, on the go, quick reading you got to take, it works fine. It'll get the job done. So I think the reason it works is because it's half. 1310, 16 divided by 2 is, what is it, 655. So it'll read. Funny thing is, if you're trying to do multi-mode, that laser doesn't work because the division isn't there. Don't ask me why, but that laser does work for measuring single mode fiber. Here's another thing. Tony, hold that horizontally if you would with the light on. Just hold that laser with the cable plugged in. Go ahead, plug the cable in. Just like that's a patch cable, just like you're patching into a wall, right? Now hold it like that. Now let us see the yellow cable. Let us see see what I mean by it? Now pull down a little bit, put a little pressure, downward pressure on that cable. Look at the light escaping under that collar right there. Remember when I said you got to strain relief your cables? Well, that's why. Not only is your light escaping the jacket, but you're putting strain on the connection too. And anytime you kink or twist them, you bend that fiber, just like I showed you in the video, there's light escaping that cable. So that's another great visualization of why these best practices are so effective. Perfect. Thank you, Tony.
It's even called a visual fault indicator.
Locator.
Yeah, locator, right? Yeah.
Yep. If you're Googling them, just look up VFL, Visual Fault Locator. They are fantastic tools. To be honest, if you're someone who interacts with fiber all the time and you want to kind of step up, yep, Visual Fault Locator. If you're someone that wants to step up and just kind of, prove that you're someone that can be trusted with fiber and knows a little more than the average worker, if you get yourself a laser, get some swabs, get a clicker, get a little cheap power meter, some patch cables, and then a couple of clean, like Tony had that yellow cassette with you, some OptiWipes. If you have that in your pack, that's a pretty nice little starter kit. And again, anybody interested in those, just email me. I can show you what they are and what they cost. They're pretty affordable. And I'll tell you, as I also do a lot of hiring. I do crewing and hiring as well. And when I see people show up on site with those, it's just a good thing to see, because they're a little more enthusiastic and a little more dedicated technicians when they show up with stuff like that. You shouldn't have to own your own tools. They say a lot of times the employer should provide them. I would agree with that, But at the same time, as an employer from time to time, it sure is a good feeling when you see people show up with those kind of tools, because you know they don't buy them unless they know how to use them. So it's just a good indicator. Let's see what's next. Okay, here's some of the swabs I use. There's that cassette that Tony had that we showed you. That's my favorite kind of cassette to use. Cheap, easy. They're refillable as well. If you pop the thing open, there's you can put a new spool in there. The Sticklers swabs on the right. Swabs are, not all swabs are created equal. The right swab for the right job, I guess you could say, if I'm being corny. Those Stickler swabs that you're looking at there, the blue ones, they are, number one, I don't know if you can see it, but they have a number on them, and it has 25 in the model number on the white packaging there. That is a ST / Sam Tom, Sam Charlie, or Frank Charlie. That's a 2.5 millimeter swab. So again, you got to know the ferrule diameter to know you're buying the right thing. And these are hard tipped swabs, okay? When they're hard tipped, they clean in a different way than the softer tip swabs do. Softer tips are more for absorbing. Tony can attest to the fact that we'll go into the XL Energy Center, right? And there's a great big fiber rack that we built in there. If you go and try to clean fiber by using your clicker, the plungers, the result is not nearly as good than if you use one of these swabs right here. The reason why is because they built it right next to the busiest loading dock in the venue. We told them not to put it there. They didn't listen to us, but every day there's trucks pulling in and out of there, blowing dust and everything. And the swabs work better for cleaning in that scenario. Now go across town over to Target Center or any other venue in town, and the clickers usually work just fine. But in that specific venue, the swabs work much better than the clickers for whatever reason. But we've actually hook up meters, and then you do testing, and you see which one gets you to the right reading quickest. And it was always the swabs at that particular venue. So kind of like the patch cables, it's good to have an assortment of stuff in your bag so you can go through the different cleaning methods and tools and get the job done quicker and figure out which one's right for the job. Those swabs come in a lot of different sizes. You get SMPTE swabs, LC swabs. You get ones that are there's a specialty. They do make a specialty tool, a little ring that you can put on opticalcon. That you push this little ring down, it opens up the flap, and you can get at it with the swab in case you don't want to how I told you you could break open a opticalcon connector like an XLR does, unthread it. Well, there's a way to avoid doing that too. So that kind of brings that. Tony, I should stop there. What do we got? Any other questions?
Just is there a cleaner for OptiCore? And if someone could demonstrate how to clean OptiCore, but I don't have an OptiCore cable.
Yeah, we
clean tools.
We do not interface very much at all with OptiCore. Most of the manufacturers will give you a recommendation. They'll give you a recommendation of what to use, and I would say if you're in doubt, go to the actual manufacturer's page and ask them and look there. They'll probably give you a recommendation, or you can even look at a video on YouTube. OptiCore cable is it's one of those specialty cables that we do not come into contact with very much. Let's see, moving on. What do we got next here? But I will tell you this as a kind of a tip for best practices. No matter what type of connector you're talking about, as long as you can get a lint-free swab clicker cassette, if you can get something lint-free on that connector and either spin it or move it around, then you're fine. We use different swabs for the raw. Like say I'm sitting there with a SMPTE connector, and those are 2.0 millimeter ferrule. It's a 2 millimeter ferrule. It's not 125. It's not 25. It's 2. But I have an LC swab with me. Well, it's smaller than that. LC is 125. So I will go ahead and use it, get it on that SMPTE ferrule, and spin it, and it works fine. So again, the idea being whatever you can get on that connector without breaking anything, obviously, go ahead and do it. Just like you can use your jeans. It's another one of those things you should have the right tool for the job, but reality speaks to us pretty loudly. We don't always have it. This is the part where we would go pass around a bunch of patch panels and stuff like that and start doing some more cleaning on patch panels. Really, the point is to say, look, there's different ways of handling patch panels than you would cables, but luckily we've already kind of covered a lot of that. Tony, any other questions?
Just are swabs single use? And
Yes.
they are.
Yeah, basically you put a little bit of back pressure on the swab, you spin it 10 times in whichever direction you choose. It's typically, if you read the side of the box, it'll say spin it 10 times clockwise, and then throw it away. And that's typically what we do too. So
yeah. I mean, you can also use, you didn't mention like alcohol, you know,
oh,
alcohol
absolutely.
for
Yeah.
the cleaners, or there are they look like wet wipes. You can use those too that are wet, but eventually you need to dry
Wipes.
it and
Yeah.
clean it off. And unfortunately, I don't have any of that stuff.
Yeah,
You
you can
also,
go ahead. Go ahead.
sorry, I think earlier the question about opticore cleaning, the question was actually about optical core,
Optical con.
optical con, yeah.
Yeah, the
Okay.
optical, which you
Op-
talked about with that ring for the retracting.
That's
Right, and
the,
also if it's a bulkhead connector, just go in the back of it. It's only an LC. Optical con connectors are LCs in essence, and they're just mounted into a shell that makes the bigger connector. So on a bulkhead, you can actually unplug the fiber from the shell and clean it like an LC.
exactly. Yeah, and like I said before too, those opticon connectors will unthread, just like if you're breaking open an XLR connector. If you've got the cable in hand, you unthread it and it'll completely expose those LC connectors. Or just like you said there, they will get them at the bulkhead.
And I think with the optical core, which is an expanded beam connector, you really need to use a swab.
Absolutely.
I think
Yep.
the only way to clean expanded beam connectors is with a swab.
Yeah, the MX expanded beam, it's got the 4 big orbs in there. That's exactly right. And I would always say do a chemical and then a dry, like anything else too. But the big, nice, absorbent kind of Q-tip looking swabs seem to work the best for that. Big puffy end swabs are always good for the optical core. I was calling them expanded beam, but it could be either or.
And one thing that you didn't touch on is angled polish and cleaning.
Yes. Don't know how many of you guys run into APC, angle polish connectors, or you know what they are. APC, the best analogy I give is basically they polish the end face of the connector. It's not flat. It has a little bit of an angle to it. And if you've ever done any trim carpentry work, whenever you're putting in baseboard in your house, you cut that baseboard at a 22.5-degree angle. It goes together better and it fits, it hides the seam a little better. Well, that's kind of the same idea they're using with angle polish connectors. Angle polish are, one of them is one angle, one of them is the other. And when you connect them together, they slide together just like I described in that piece of baseboard. The advantage to angle polish connectors are they advertise that they reduce loss. When two ends come together, there's always going to be a little bit of loss. It's called back reflection by a lot of manufacturers. Angle polish reduces that. Now, if you are anyone who's worked with shed boxes, SMPTE hybrid, you know, the camera shed boxes, if you were to open one of those up, you'll see what's happening in most of them. The ST connectors, if it has an ST connector coming off of it, or the SMPTE connector for that end, they marry together inside the shed box via an APC connector. Another thing you could compare an APC connector to, it's like a humbucker. A lot of guys will use them at the end of the line of the signal when it goes out to the camera and then it comes back. An APC can be introduced to the end of the line in the same way you would do a humbucker. The hum in this case, in that case of fiber optics, we're calling the hum back reflectance, okay? Well, we can get rid of that back reflectance by using a nice clean APC connector. It's a little known trick, but APC connector, you can buy those in adapter patch cables just like you can buy the other patch cables we've been talking about, like the ones Tony had. They're typically like a lime green color, okay? An APC connector is a great, especially if you're someone who's dealing a lot with 4K. I'd say if you're just dealing with audio and data, I wouldn't really trouble yourself at all with APC. But if you're dealing with 4K cameras or super slow-mo, really high bandwidth information paths, APC connector, if you just break, if you break open at a junction, any intersection where the cable is, you undo the connection and introduce an APC connection to it, and then just send it out the other side back, turn it from ST, SAM-TOM, into APC, marry it to another APC connector, and then the other end of that cable is SAM-TOM. You just introduce that little connection in there, you will clean up a lot of the back reflectance. And that's why they are installed in many of the manufacturers' boxes that make the shed boxes, even multiplexers, and the Telecast makes a lot of boxes that they will have an APC connector in there, and that's specifically what it's doing, is it's lowering the back reflectance. A really good way to describe this, the way I do it in class, I'm sitting here doing it now, realizing you people can't see me. If you take the knuckles on your pointer finger, bend the knuckles in all the way into your wrist, and then push your knuckles together, point to point, okay? When you do that, that's the type of connection, the type of physical connection that is happening with a standard connector, which is called a UPC. UPC stands for Universal Polish Connector. That's 99% of the stuff you see out there, that just like Tony was showing you too, those are UPC. They are polished flat with a beveled edge around them. When those two connections meet, you might have one cable that was built by a guy with, by hand, somebody polished that by hand, and the other end was built by a machine. So if you're able to magnify that connection and look at what's happening there magnify it by 1,000 times, there's going to be high points on both of those end faces. There's going to be high points that touch first, okay? When the high points touch, there is also a little bit of an air gap left in there, okay? That air gap is what back reflectance is. And if you look at video, anybody on a TV truck nowadays, you're looking at cameras, in the middle of the video bench, there will be an MSU, a master sending unit. There's a meter on there. They've built them in, these manufacturers, called reflectance or back reflectance in some cases. That's exactly what it's measuring, because when there is an air gap in between two fiber connectors, the light bounces back and forth. It ping pongs in there. And the tricky part is you won't be able to detect that with a standard little handheld power meter. You can get really good readings off of your optical power meter and say, hey man, there's only a point or two of loss on this line. It should be working great, but yet it won't fire. It won't go through for you on these super slow-mo or 4K cameras. What is oftentimes happening is too much back reflectance. Like I said, luckily a lot of the manufacturers are putting those meters in. A great way to get rid of that back reflectance is using an angle polish connector. There's another trick, using something called focusing gel. If you introduce a little bit of focusing gel into one of the connections, that focusing gel, it's kind of like a Vaseline type substance. It has very much the feel of Vaseline. It's made by like Fiber Instrument Sales sells it. Focusing gel, you take a Q-tip and dab a little bit in there with a swab and then push the connection in. That'll also get rid of back reflectance. The bad thing about that is you forget to clean it out and you really hose the next guy that's going to use the connector. So I only use those in really extreme examples, but it's a great trick to use. I'm glad you brought up APC, Tony. Thank you. What else you got?
He wants to know what the best tool is for cleaning SMPTE fiber. One thing that you didn't bring up was this little.
Well, that's the extraction tool. Yeah, I talked about that.
Tool.
So that's where I said.
Just screws into the SMPTE cable connection. You pop that off, and then you're able to get a swab in there.
The number one thing I would say is, I think Pete had it earlier, his IBC clicker. IBC makes a clicker, and on the side of it, it'll say M20 as in Mary 20. Pete's happens to say SC as in Sam Charlie, but IBC also makes an M20, which is a SMPTE clicker. That is the number one tool for cleaning SMPTE, is to click out. And as you saw, it had the male receptacle on when you pulled the little cap up, and then you pull the gray cap all the way off. Now you can get at the female inputs of the fiber. That's all you should be doing, or using a swab, like I showed those stickler swabs. They make them for SMPTE as well. These little blue ones. They make orange ones that are meant to fit inside SMPTE connectors. Swab it or click it. That's the best way to do it. If you're someone who feels comfortable taking off those alignment sleeves with that tool Tony just showed, go for it. But make sure you're talking to whoever owns that cable and they're cool with you doing it. If you remove the alignment sleeves And I'm going to back way up here and show you what I mean. Right, that's a good shot right there. You look at that silver, it's a Limo SMPTE connector. The alignment sleeves are the two silver circles that are, one is on the top, one is on the bottom. If you take that Limo extraction tool that Tony just had and you push it in kind of hard using more force than you might think, and you spin it, it threads on. You thread it on there, you hear a click, and then you pull it out, and it'll pull that alignment sleeve right out of there. Once you remove both alignment sleeves, there's more room to clean the ferrule, because underneath those alignment sleeves, inside of them, I should say, is the white ferrule. That's how you can clean it. And then when you go to put them back on, you have to push really hard. It gives you a click. You feel it kind of go into a detent spot, and then you unthread it, and you're back in business. But like I said, a ton of the repairs that we do are because people forget to put the alignment sleeves back in place. So just be wary of that. Bottom line, get an M20 clicker or get some swabs. Anything else, Tone?
Just going through this one more time, sorry. To confirm, you must connect an angle polish connector to an angle polish connector, or can you connect an angle polish connector to a non-angle polish connector?
Another good question. It has to be APC to APC. It will not connect to another type of connector. But they make patch cables that has the APC on one end and a UPC on the other. And that can be in, you can get an angle polish on a ST connector. You can get angle polish on a LC Larry Charlie or Sam Charlie. Any single connector can come with them. The most frequently you see though is a Sam Charlie. Typically it's the Sam Charlie connector with the angle polish to it is what you most frequently see. And you do indeed have to connect it to another angle polish or you will break something. So another very good question. What else you got?
Keep going. I'll get you on here.
Okay.
In a second.
So we're wrapping things up a little bit. Again, devil is in the details. All these best practices, caps, the good ones, there's bad ones and good ones. If I could show it to you. Honestly, if you see metal caps or caps made out of a hard nylon material, those are the best caps to use. If they're made out of soft rubber material, they're very likely to leave a residue on your connectors, okay? So metal or hard vinyl, good. Softer rubber caps, bad. Bad for leaving residue anyways. Don't assume test. Get used to using your meters is what I'm trying to say there is, even when things are going good, I know it's scary to touch something when it's working, but if you got the right scenario, grab your meter and hook it up and just take some readings and do some comparison. It's a really great way to kind of just know what to look for and learn how to read this stuff. Use that magnifying scope that, like I said, I'll hit it again. That scope is more importantly, it's a teaching tool. It'll teach you what your cleaners are doing and what's happening to the end of that connector that you can't see by the naked eye. Strain relief is critical. Tony did a great demonstration of that earlier. If you're not strain relieving your fiber, you're losing some signal strength. And it is usually something simple. Reseat it. What is it the old saying? Keep it simple, stupid. Reseat it, clean it, plug it back in, shine light down it to make sure you're sending it down the right side. Or even better yet, you don't have to shine light down it. Get your meter out. If you're in a booth and someone's back at the control central there, someone's back at the truck or back at sitting at the fly pack saying, hey, fiber line number 1, it should be working. And you plug it in, it's not working. Bust your meter out. If they're sending to you, if they're transmitting a signal, plug your meter in. When you plug it in, if the numbers don't move, there's nothing coming. And that's a great way to save time instead of the other guy on the other end goes and gets his laser, and then he unplugs it, and then he can't find his laser. Now the batteries are dead, blah, blah, blah. No, just unplug that line. He says they say they're sending fiber down, plug it into your meter. If the numbers move, then you got something. If they don't move, they're not. It's a great way to really shorten up that troubleshooting. And then, use the test patch jumpers to protect your gear as well. That's something we didn't really touch on, is that those patch jumpers, when I'm testing using my meters, Tony can tell you this, I almost never do I plug fiber directly into anything I own. I usually plug it into a patch cable. I barrel it onto the patch cable. The patch cable goes into my tester or even my fiber converters. Don't plug field fiber directly into the back of your rack if you can help it. Don't plug it back directly into your converters or your test gear. Try to jump it whenever possible. Try to patch it into a jumper first. That way, you ruin or foul up the jumper, that's like $10. But you foul up your gear, now your gear's out of service and it's a lot more expensive to get it fixed. So use those patch cables for more things than just one. Protects your gear and can save your show in certain circumstances.
Question here is,
Yeah.
should a SFP spec sheet state that it is single or multi-mode?
Yeah, absolutely.
And the second part of that question is 850 nanometers almost always a multi-mode?
It is always a multi-mode. That is correct. Yeah, some of those SFPs, I wish I could show you what an SFP is for those that don't know. SFP, if you can imagine an Aja FIDO converter where the cable plugs in, little silver receptacle. Oh, look at you. God, I gotta get you. I'm gonna have liquor delivered to your house. Oh, look at you guys. You're just killing it. Those are SFPs, really cool little modules, and they're really cheap nowadays too. They plug into the gear on the backside, like Tony is showing you there. So if you got an Aja or a different kind of fiber optic device, you can swap out SFPs so they can take different types of connectors, like Tony's showing us, or they can you can even do different wavelengths if you have the right kind of box. Those SFPs, Sam, Frank, Peters, are interchangeable. They pop right up. Go ahead.
One thing to mention is multi-mode can only do one signal down the line, whereas single mode can do several signals. This is a bidirectional SFP, comes in an A and a B version. You put an A on one end of the line, a B on the other end of the line, and your two channels of light go together, shooting against each other.
Yeah, you're exactly right. With one exception, what I'll say is that it really depends on the box. The gear is what's going to limit you to how many signals you can send down the line. The glass doesn't care. The glass will.
No, the glass doesn't care. You're right, but I mean a bidirectional SFP will use two lights.
Yeah, this is not wave division multiplexing. This is actually it's signal in both directions.
Correct.
So for a network, you would use one fiber instead of using a dual to make your network connection.
Yeah, great example. Thank you for showing that. That's a great example. You got some impressive. You got that little meter. See that little meter he's got there? That optical power meter right there? That's about Amazon. You get them for 28, 35 bucks.
Nothing.
Yeah. And they work, and they also have a laser with them. He just turned it on right there. You put your finger in front of it.
And reads.
Now, here's what I'll tell you.
Multi-mode.
Yeah.
On the meter.
Reads, 6
and
different
when you
wavelengths.
plug it into your test cable, a little short cable, press 0, zero's the meter, and then you plug it into your cable to be tested and you read the exact loss on the cable.
Exactly. Now I found the first one that I ordered of that, it quit working right away. It's like, what the heck? So I pulled the box apart. What you'll find on that particular model is, at least the ones I have, the diodes were not soldered onto the circuit board. They were just friction fit.
That was extra.
Yeah.
You paid for this soldered PT board.
Yeah. So I pulled it apart and it's like, oh, it's just like friction. It's just like a little spring fork. The diode is onto the board. So I just put 2 little dabs of solder and the thing worked great after that. It's never failed. But those are good. Good little boxes for nothing. And like I said, if you lose it, break it, who cares? It's 25, 30 bucks. Good things to have in your toolbox. But yeah, just to build off of what Pete was saying there too, is great thing about those little SFPs is a lot of the bigger shows, you'll see that they have a rack set up with all the fiber for the show coming into it and going out of it. And oftentimes what's in there, what they're doing is they're multiplexing, they're blending a bunch of fiber signals together. And then on those SFPs, they'll come up, you'll see they'll have little mini plugins like mini BNC or mini HDMI or even mini XLR I've seen, which then you can take a cable out of the mini version of that and go into a standard size version of that, and you can turn anything into anything. One of the cool companies out there doing that is Barn Find. Barn Find, they were nice enough to borrow us a box too when we did our classes in LA. Really cool, incredibly interchangeable in every single way. they love using them on the bigger shows, like say All Star or Emmy or something, where they'll use them as even a redundant path. They'll introduce multiplexing, and then they'll have a bevy, just a ton, an array of those SFPs on hand. So somebody's like, hey, I need this cable over here, and oh sure, they literally pull it out and push a new one in, and now you've got your solution. So pretty cool little devices. Tony, any other questions you got from the chat?
I was actually gonna say I gotta take off here. The family is calling.
Yes, sir.
Yeah. Hey, Tony, it's Kelly here. I
Hey.
want to say thanks for jumping on. If you don't mind, Jesse, if you could just hang for just a couple more minutes. We've got just a couple little things, questions here, if you don't mind. But Tony, thank you so much for being a part of today, man.
Yep. Thank you guys. Again, I always enjoy these. You guys
All right.
have a
Well,
good night.
you've been on episode 40, episode 50, and we'll call you on episode 60. All right.
Sounds
So-
good. I'll see you then.
Have a good weekend, buddy. Jesse here, Mac or Pete, if you want to click on, maybe we'll throw up Jesse's photo so we make it feel like he's connected with us. This has been awesome. A couple notes. I think that I saw one from Henry, because Henry Cohen and I had an opportunity to work together on an RF over fiber project, and that's where I learned very quickly about APCs and Foxtrot Charlie connectors, and what to cross the streams and universal versus APC. And when it doesn't work, you learn very quickly what doesn't work. Let's see here. Point the difference between single mode and multi-mode ST barrels. That's an interesting one.
Somebody climbed down the rabbit hole. Yeah, so
Yeah.
there actually is a difference. You can, which makes zero sense at all. The outer diameter of a ferrule is 125 microns. I'm sorry, is 2.5 millimeters. If we're talking ST Sam Tom, it's a 2.5 millimeter ferrule. That's the diameter. Whether inside of that ferrule is a multi-mode opening versus a single mode opening should make no difference. However, they do make them. And the bad part is some manufacturers, you can tell by a giveaway, a visual giveaway on them. Some of them you can't. So
One thing I've found is the inside of the ST barrel, if it's metal,
yes,
I call that a multi-mode connector. And I only use ceramic ST barrels
exactly.
because it aligns it much better.
And that's the safest bet, is to look for that ceramic interior instead of a metal. But that's the crazy part, is some of the metal ones are single mode. They just, older. There wasn't a standard made, but that what he just said is exactly what you should go by. And hey, here's another thing I'll tell you, is that I'm glad you brought that up. Barrels are often the problem. These barrels have to be machined so specifically because, like I keep saying, we're lining up 2 9-micron little beams of glass, little lasers. The barrels sometimes get manufactured incorrectly. So
It's pretty precision stuff.
Oh my God, yeah, down to, we're talking microns here, right? So if you're pulling your hair out and you can't figure out why something's not working, go to the barrel. Yeah, Pete, you got a good visual for us there if you want to. Those barrels, you may be looking at a bulkhead and not even considering them to be a possible part of your problem. Well, they are. A lot of times you'll move around and say, oh yeah, channel 1's working, but not channel 2. Well, a lot of times that's because of the barrel. And if you have any barrels that are just, free floating barrels in your line of just try changing them and see what the meter says, because we find quite a bit. If you're talking a BNC or audio barrel, we've all run into that where you look at them and they're hollow, there's no guts to them, and you connect it, you're like, oh crap. Well, fiber, they are hollow barrels no matter what, but they're not machined precisely enough sometimes, and those can be your problems. Those will make you pull your hair out because you don't think of them very often.
Yeah, 50 to 75 ohm barrel, not such a big deal.
Right. Yep.
Fiber optic barrel, bit of a deal.
It's a deal. The little laser
This
needs
is an actual bulkhead connector you can buy for a modular rack, but I buy a dozen of these or so, and I hang them up where my fiber patch area is, and that way the stress is taken off the cables.
Yeah, it's a
I'm
good
not
one.
hanging the cables by it. I just sort of hang them like this and run one cable in one side, one cable on the other side.
Yeah, it's a really good way to do it. I like that. What else you got for questions there, Kelly?
Well, I'm just going through here. I like this one from Scott. Swab it or click it is his new phrase. The phrase that pays. Swab it or click it. I think there's actually a game there. Maybe Hasbro can build something out of that. But I think to your point, like Pete showing the strain relief. It's really this fiber is all about cumulative, right? Doing little things all the time that just make the overall performance better. We just can't take that for granted anytime.
Particularly with RF over fiber, because
Oh,
it's
yeah.
an analog signal.
Yes, good point. What else you got?
What is SPC as polishing as a return loss reading?
Say that again. What is?
Yeah, John, if you could maybe retype that for me. What is SPC as a return loss reading or solid? And then he follows it up with polishing. Like, in other words, what the reading maybe before or after? So John, just go ahead and throw another one in there, and here we go. UPC, APC, SPC. Okay, so all relative to what is that loss reading in terms of what should it be? Not sure there. I'm gonna work on that one, John.
Yeah, I don't know that
I think he's probably getting at what is the difference in return loss between
the type of connector,
the
right?
types of connectors, between an
Two
angle polished
UPCs
connector
versus
and
an
a
angle,
universal
right?
polished connector.
Yeah, gotcha.
well, that kind of
SPC. There you go. Polish.
that
What
would
is it?
drive at the really kind of drives at the method of metering you're looking at. Loss is measured differently than back reflectance is measured. So, for instance, if you're looking at an APC connector, APCs were specifically manufactured to help reduce loss. They were seen as a tighter fit, a better flush connection. And if you see them in our world, they're typically introduced because there was a problem. So I don't know that I have a real clean, easy answer for you there. You really
Yeah,
have.
no, I think that's okay. What is SPC? I think is more, if you've got APC, APC, UPC, his with the S, obviously with angled, we have more surface area touching, right? Versus the beveled edges. So you're always gonna have just a little more, but I'm gonna work on that. What is the large meter in Jesse's photo?
Oh man, they don't make them anymore.
It looks expensive.
But to answer your question, SPC stands for super physical contact.
Okay.
But it's, man, I never see them. I only know about them because I nerd out and go on FOA.org, and I've never even worked with them, so I can't be too helpful there. And I should correct myself too. UPC, we always call it universal polish. It's actually ultra polish, not universal.
Right.
But nerd
I
cred.
think we all consider it universal though.
that blue box, I used to sleep with that thing under my pillow, man. I sold about 90 of those online, but they quit making them in the right way, so to speak. It is a test everything kind of meter. I can test fiber. My best meters are Owls. They're manufactured out of Wisconsin, and I put that tester up against my Owl, and it was spot on with my Owl, so I could trust it just like I do my best meters. And then it's also got a voltage meter in there. It's got HD SDI monitoring. It's got standard def monitoring. You can test data, VGA. They make a model that'll take HDMI in. It's got a Phoenix connector. It's got a Fox and Hound. For those of you who know that, that's a little bit older technology, but for tracing lines, you can put Fox and Hound type signals on there. Then you take what's called a sniffer to the other end of the line. Used a lot in older telecom kind of purposes.
Yep. Beep, boop, beep, boop, beep, boop.
Yeah, exactly. It lets you select a bunch of them. Internet testing, it's great. A lot of times I'll serve as the a facility engineer sometimes for some of the venues in town. And if somebody says, "Hey, I'm supposed to have internet on this port. There's nothing there." This thing will test internet. It does power over Ethernet testing. There isn't much it doesn't do. The bad thing is when they updated them, They no longer do they have the ability to test 5994 video. They will only test 60 hertz video, which is a closed caption. It's closed caption scan rate. So if you try to hook up a regular old, SDI feed to the new ones, it won't work, which is a total bummer because the new ones have all kinds of other cool features. They got Wi-Fi testing and touch screen. You could put XL on the new ones. I ordered a couple of them. I was geeking out, and then I realized, oh my God, it doesn't work. The SDI, which is the most used, using it as a monitor for testing, is the best aspect of it. The old ones do, the new ones don't, and you can't get any more of these, as far as I know. If you find them again, call me. I used to order them by the pallet full. So good.
Yeah.
Yeah.
Can you find a tester on eBay? Very
Yeah,
possible.
absolutely. Yeah, they're
Yeah.
all for sure. But I would say buy new, buy the buy the little $40 one if you're getting started. Start with the cheaper $40 one, or the one like I think Pete was showing us earlier that the Amazon had. Just type in fiber optic power meter, or better yet, call me. I'll get you the right stuff, and there you go.
Well, and
Yeah.
that kind of leads to that.
This
So
goes from about $300 used to $1,000 with a full cleaning kit. Also
that-
includes a
that a
little
long one?
probe
Is
for
that a-
sticking into the wall, and all the adapters fit all the different devices.
Well,
But it's very fragile. You drop it once, it's dead.
yeah, that's a probe device with all kinds of other. So
Yeah.
just like I was talking about remember when everybody remembers when I mentioned the handheld microscopes? Well, that probe is for magnifying images that are in inputs. You can put that into an input on a box or a rack, and it'll magnify the end of the connector for you. It's also got cleaning abilities. I think I see a swab plate on there. But yeah, great image. Yeah, right there. There's the image of the end face. I've got one made. I deal directly with a couple manufacturers, Aja and then Lytel. Lytel is a fantastic one out of Washington, not far from Seattle. The one I use in class, it's a scope like that, like he has. It's a probe, but it's hooked up to a Wi-Fi adapter. So I can, and then the students, attendees can download an app on their phone that connects to the probe, and they can look at the image that we see on Pete's screen there. They can look at it on their phone, holding it right in their hand.
That's actually so your boss can watch how good you're doing your work.
That's why I started my own company. I got caught too many times. So
There we
that's
go.
right.
So you had to do. Yeah, that little Wi-Fi adapter made by Lytel is a fantastic tool, great teaching tool. And then they make boxes just like Pete has there too. You can get lucky every once in a while on eBay and find one for sure.
So
Yeah,
one of the questions is, what is the model number of the power meter? Let me turn my camera back to the other camera here. This level, the good news is, I'll show you the model number and you have to write it down. Got it? You got the model number?
Got it. I got it.
Okay, it's on there, believe me.
So,
You go to
and I think,
Amazon or
yeah.
type in
$5, you take
fiber
what
optic
you
power meter, you'll see it. It'll pop up eventually on your feed. It's optical power meter.
so
Yeah, Google is your friend.
Google
There you
is your friend, and I think that's a good point here. Okay, so the Lytel model number, the question kept coming up, I think, in a few different places. Can you give us the recommended, gear, right, to get? So I'm gonna kind of wrap up the session, I think, with this, because Jesse, we talked about this on the phone beforehand, and you have so many awesome resources. I would propose, let's get a recommended list from you, Jesse, of the stuff you sell, that you would say, hey, if here's the basic kit you'd recommend, and then, if you want to step it up a little, the Lytel, obviously, I noticed from a number of names that were on the webinar today, these are folks that we all know in our different circle of people that are working with fiber on a very regular basis. So let's put that list together. I will commit to sending that out to everybody who had an email, registration for this, with the Fiber Guy list of that gear recommendations. It's all stuff that Jesse sells. Like he said, this isn't so he can get rich on this stuff. The margins on this is nothing.
Of course, remember, Jesse can offer that entire list of equipment for a special, practical, show.
$99.95. You have to order now, and then you'll get 3.
If you order right now, two sets will be sent to you with no extra handling charge.
That's right. As long as you pay twice, you can buy everything twice. That's our rule.
Exactly.
You just have to pay full price. But it sounds like your mic shifted off, Pete. We'll get that list together for everybody because we obviously saw a ton of different test gear here. And thanks for all the folks that held on, because we know who the diehards are here. Yes, this will be available on our website to watch later. That was one of the questions. You know, Jesse, I can't thank you enough, man, for being a part of this. The information you brought was brilliant. And
yeah, it's my
great job. The handouts, everybody saw the handouts, right? It's in there. All the slides were there. That was another question. They are in there. I hope we're going to have to do a best of show, guys, where we'll bring in all these top topics, and it's just Jesse's on the air. What's your question? Right. And we'll do rapid fire, you know, top 10 fiber questions, top 10 RF questions, top 10, whatever. So thanks, man, for being a part of this, for joining. And
we'll have to get you in for an AVR session to sync your picture with your words. So
I like it. No, thank you, Kelly, especially for reaching out. And it's an absolute pleasure to do this. It's something that I really love to do. I've taught classes all over the country, and it's just fun to see people light up and connect the dots and help them just get better and go out and show people, hey, we know what we're doing. You want to doubt us? Well, we've got some more information now that can make us look a lot better than maybe you were thinking. So it gives me it's a very rewarding thing to do, and I'm glad for the opportunity. Thank you all.
Yeah, no problem. And this is a step up moment for everybody. When we go back to work, being prepared to play with light better and work with light. I think we could all agree that across, whether it's audio, video, data, whatever we're doing, being better prepared is going to be key. So thanks again, everybody. Have a great weekend. Next week, we're still on the air, 3-day a week. Let's just do a quick rundown of next week topic. Let's see, Monday, we're starting with just building a creative show in a virtual world now. We're going to be talking with John Featherstone, a lighting designer that does a lot of stuff both for huge corporate events and the simplest. And how do we translate this now to a virtual world? We are not going to be doing shows with tens of thousands of people for a while. And how is that going to be different, right? And how do we still make a compelling story? The 13th, we're doing 2 sessions. We're back to working 2 a day, guys. The first session, lunch, is going to be really about business. How do we as business people, because we're all business people. If you're an independent engineer, you may not think of it yourself as a business person, but you are. You are in control of your own company. And how do you try to make it through this time? This is going to be a rough time, guys. It's not, and ladies, it's not going to get easier, better, you know, next week. So we have that set, shoot, strike, the 3 S's, 5 hours to load in a TV broadcast. And then finally, Friday, the 15th in the afternoon, we're going to have Michael Johns and Dr. Mark Kinkle from Shure, all about Axient Digital. All right. So it's going to be about what makes digital RF really work in high noise environments. Why is it something we should embrace even more, right? So going to be a great week next week. Keep an eye on our website. We're going to have some smart topics coming up. We're going to have LED walls, you name it. I mean, we got some interesting stuff in the weeks to come. Any closing thoughts, gentlemen?
No, it's time to close.
Yeah.
I have to go and clean all my fiber now. Goodbye.
You go clean your fiber. And Jesse, thank you, buddy. And everybody have a great weekend.
Too, Kelly. Thank you, guys.
All right.
Thanks again.
So
Good
long.
night.